Let's now continue learning important JavaScript features. And one topic that we haven't touched yet is asynchronous JavaScript. So the goal of asynchronous JavaScript is basically to deal with long-running tasks that basically run in the background. And the most common use case of asynchronous JavaScript is to fetch data from remote servers in so-called AJAX calls. And so that's what we will do in this section, while learning everything there is to learn about promises, the fetch function, async await, and error handling. So this is yet another really exciting section, and so let's get started. Let's start this section by understanding what asynchronous JavaScript actually is, and also learn about the most popular use cases of asynchronous JavaScript, which is basically to make so-called AJAX calls to APIs. Now, to understand what asynchronous JavaScript code actually is, we first need to understand what synchronous code is. So basically the opposite of asynchronous. So most of the code that we've been writing so far in the course has been synchronous code. And synchronous simply means that the code is executed line by line in the exact order of execution that we defined in our code, just like in this small example. So as the first line of code is reached in the execution, it is simply executed in the execution thread. Now don't worry about this execution thread. It's not important here. It's just to make a point of synchronous versus asynchronous code, as you will see in the next slide. All you need to know is that the execution thread is part of the execution context, which does actually execute the code in the computer's processor. But anyway, then the next line of code is executed, and then the next one, all in sequence. So each line of code always waits for the previous line to finish execution. Now, this can create problems when one line of code takes a long time to run. For example, in this current line of code, we have an alert statement which creates this alert window. Now, as we've experienced in the past, this alert window will block the code execution, right? So nothing will happen on the page until we click that OK button. And only then the code can continue executing. And so the alert statement is a perfect example of a long-running operation which blocks execution of the code. So again, only after we click OK, the window disappears and the next line can run. So this is hopefully a nice illustration of the problem with synchronous code. Now, most of the time, synchronous code is fine and makes perfect sense, but imagine that execution would have to wait, for example, for a 5-second timer to finish. That would just be terrible, right? Because meanwhile, nothing on the page would work during these 5 seconds. And so that's where asynchronous code comes into play. So this example contains the 5-second timer that I just mentioned. And if you want, you can pause the video here for a minute and analyze this code before we move on. Now, anyway, the first line of code is still synchronous here, and we also move to the second line in a synchronous way. But here we encounter the setTimeout function, which will basically start a timer in an asynchronous way. So this means that the timer will essentially run in the background without preventing the main code from executing. We also register a callback function, which will not be executed now, but only after the timer has finished running. And we have actually already done this many times before in practice, right? Now, this callback function that I just mentioned is asynchronous JavaScript. And it is asynchronous because it's only going to be executed after a task that is running in the background finishes execution. And in this case, that is the timer. So this callback that we just talked about is registered, and then we immediately move on to the next line. So the main code is not being blocked, and execution does not wait for the asynchronous timer to finish its work. And that's the big difference between synchronous and asynchronous code. So previously, we had to wait for the user to click on the alert window to continue execution. And again, that's because alert is blocking synchronous code. But now, with this timer, the callback is actually asynchronous. And so it's only going to be executed after the timer has finished. And so therefore, we say that it's non-blocking, because in the meantime, the rest of the code can keep running normally. Now, when the timer finally finishes after 5 seconds, the callback function will finally be executed as well. So you see that this callback runs after all the other code, even though in the code it doesn't appear at the end. And so basically, an action was deferred into the future here in order to make the code non-blocking. And actually, we already saw this behavior happening before when we first learned about timers. We just didn't know that this is called asynchronous and non-blocking code. So in summary, asynchronous programming is all about coordinating the behavior of our program over a certain period of time. And this is essential to understand. So asynchronous literally means not occurring at the same time. And so that's what asynchronous programming is all about. All right. Now, as we saw in this example, we need a callback function to implement this asynchronous behavior, right? However, that does not mean that callback functions automatically make code asynchronous. That is just not the case, okay? For example, the arrayMap method accepts a callback function as well, but that doesn't make the code asynchronous. Only certain functions, such as setTimeout, work in an asynchronous way. We just have to know which ones do and which ones don't, okay? But please understand this very important fact that callback functions alone do not make code asynchronous. That's essential to keep in mind. But anyway, in order to really understand this, let's see another example. So this example is about loading an image. So the first 2 lines run in a synchronous way, one after the other. Now in the second line, we set the source attribute of the image that we selected in the first line. And this operation is actually asynchronous. So setting the source attribute of any image is essentially loading an image in the background while the rest of the code can keep running. And this makes sense, right? Imagine that it's a huge image. We wouldn't want our entire code to wait for the image to load. And that's why setting the source attribute was implemented in JavaScript in an asynchronous way. Now, once the image has finished loading, a load event will automatically be emitted by JavaScript. And so we can then listen for that event in order to act on it. Listening for the load event is exactly what we do here in the next line as well. So here we use addEventListener and register a callback function for the load event. So just like in the previous example, we provide a callback function that will be executed once the image has been loaded and not right away. Because again, all this code is non-blocking. So instead of blocking, execution moves on right to the next line immediately. Then once the image is completely loaded, it's displayed on the web page and the load event is emitted. And since we're listening for that event, our callback function is finally executed. So once more, we deferred an action into the future, making the code asynchronous and non-blocking. All right, and so now at this point, I believe that you have a pretty good understanding of asynchronous code. There is just one more important thing that I need to mention, which is the fact that event listeners alone do not make code asynchronous, just like callback functions alone do also not make code asynchronous. For example, an event listener listening for a click on a button is not doing any work in the background. It's simply waiting for a click to happen, but it's not doing anything. And so there's no asynchronous behavior involved at all. Now, what makes this code example asynchronous is simply the fact that the image is loading asynchronously in the background, but not the fact that we are listening for the load event to happen. So what matters is the asynchronous behavior of a task, like running a timer or loading an image. And there are more examples of asynchronous behavior in JavaScript, like the geolocation API that we used before, or AJAX calls. And AJAX calls are probably the most important use case of asynchronous JavaScript. And so let's see what AJAX is all about. So AJAX stands for Asynchronous JavaScript and XML, and basically it allows us to communicate with remote web servers in an asynchronous way. Now in practice, we make AJAX calls in our code in order to request some data from a web server dynamically, so without reloading the page, so that we can use that data in our application dynamically. For example, right in the next video, we're going to make AJAX calls to request data about countries. And we can then use that data about countries to build a small application that shows us information about the country that we're currently in. And the possibilities and use cases are endless, but more about that in the next slide. For now, let's quickly understand how AJAX works. So let's say that we have our JavaScript application running in the browser, which is also called the client, and we want the application to get some data from a web server. And let's say the data about countries that I was talking about earlier. So with AJAX, we can do an HTTP request to the server which has this data. And the server will then set back a response containing that data that we requested. And this back and forth between client and server all happens asynchronously in the background, just the way we learned before. And there can even be different types of requests, like GET requests to receive data or POST requests to send data to a server. But there is a whole lecture about this a bit later to really show you how it all works in detail. Now, when we're asking a server to send us some data, this server usually contains a web API. And this API is the one that has the data that we're asking for. So an API is something pretty important, and so let's now see what an API and web APIs actually are. So first of all, API stands for Application Programming Interface. Now, in general terms and on a very high level of abstraction, an API is basically a piece of software that can be used by another piece of software in order to basically allow applications to talk to each other and exchange information. And that's true not only for web development and JavaScript, but for programming in general. Now, in JavaScript and web development, there are countless types of APIs, like the DOM API or the geolocation API that we have been using. So these are called APIs because they are a self-contained piece of software that allow other pieces of software to interact with them. For example, our map-t application that we built in the previous section. Also, we can always implement a small and simple API in a class where we make some methods available as a public interface. Remember? So again, objects made from a class can be seen as self-contained, encapsulated pieces of software that other pieces of software can interact with. And so that fits the definition of API, right? But now let's talk about the important type of API that we are actually interested in when we use AJAX. And that are APIs that I like to call online APIs. So an online API is essentially an application running on a web server which receives requests for data then retrieves this data from some database and then sends it back to the client. So just as we saw in the last slide, right? Now, when building applications in practice, we simply call these online APIs API. And many people will also call these APIs web APIs, or again, just simply API. So the term online API is actually a term that I came up with myself, because the term web API is actually also used for other things. Now, of course, we can build our own online APIs, but that requires back-end development. So development with servers and databases and all that. And this is something really interesting that you can learn after this course. And I actually have a course on Node.js myself that you can check out if you're interested. But anyway, for now, we are interested in using third-party APIs. So APIs that other developers make available for us, most of the times for free. So let's now imagine that you're building a traveling application and you have a database with different destinations and tours that you're offering. So on your own server, you could build your own API that can receive requests from your front-end application in JavaScript and send back the results. So that would be your own API hosted on your own server. But that alone would probably not be enough to build a complete application. And so you could also use some third-party APIs. And there are really APIs for everything. So in our example travel application, you could use an API to get weather data in your destinations, data about the destination countries themselves, data about flights, about currency conversion, and you could even use APIs to send emails or text messages or embed Google Maps into your applications. So as you see, the possibilities are really endless with APIs. And we can even say that APIs is what made the modern web, as you know it, possible in the first place. So using APIs in JavaScript is super popular and everyone does it all the time. And so that's why I'm explaining you all these details. Okay, but now just to finish, let's quickly talk about API data formats. So AJAX stands for Asynchronous JavaScript and XML. Remember? So the X there stands for XML. And XML is a data format which used to be widely used to transmit data on the web. However, these days, basically no API uses XML data anymore. The term AJAX is just an old name that got very popular back in the day, and so it's still used today, even though we don't use XML anymore. So instead, most APIs these days use the JSON data format. So JSON is the most popular data format today because it's basically just a JavaScript object but converted to a string. And so therefore, it's very easy to send across the web and also to use in JavaScript once the data arrives. All right, so now that we know what asynchronous JavaScript is and also what AJAX and APIs are, let's finally use all this in practice and make our very first AJAX call in the next video. So now that we know about AJAX and APIs, let's actually make our first API call. So in this lecture, we're going to build a nice UI component such as this one here, which contains data about a certain country. And this data about the countries is actually going to come from a third-party online API. So just as we learned it in the last video. So here we have this first card for Portugal and then another card for the USA. And of course, this would work for any country in the world. And this is actually really exciting stuff to me. So I think it feels really magical and next level to be able to do this. So to kind of magically get this kind of data from the internet and then work with it in any application that we're building. And so let's now start working on this. And as always, I already have my starter files up here in VS Code. And I also already started the live server. And so that's what I have here open. And so now let's get to work. Now in JavaScript, there are actually multiple ways of doing AJAX calls, but we're going to start with the most old school one. And that's called the XML HTTP request function. So we can do new XML HTTP request. So just this one here. So we call this function, and then all we need to do for now is to store the result in a new variable. So let's call this one request. And so that's the first step of using the XML HTTP request way of doing AJAX calls. Now, again, as I mentioned, this is the old school way of doing AJAX in JavaScript, but I'm still showing it to you for two reasons. So first, I want you to know that XML HTTP request exists because you might actually need it in the future. And second, I want to show you how AJAX calls used to be handled with events and callback functions. And so only after that, we should move on to a more modern way of handling asynchronous JavaScript, which is going to be a feature called promises. But anyway, next we need the URL to which we will make the AJAX call. So we can now say request, so that object that we created here, dot open. And then here, first we need to pass in the type of request. And remember that the type of HTTP request to get data is simply called get. And second, we need a string containing the URL to which the AJAX call should actually be made. So let me now show you the API that I selected for this project and also how we can use it so that you can actually understand how you could do something similar yourself. So on GitHub, there is this huge repository, as you can see here, which is called public APIs. And so if you just Google for that, I'm sure that you will find it. And here is a list of a ton of public and free APIs that you can use. So we have all these different categories here. And so there's really an API for everything. So just as I said in the last video. And the one that we are going to use is called REST countries. So it's this one here. All right. So we see here that, well, this is a big table. So we see that the API we are going to use needs no authentication. I think it uses HTTPS, and I'm not sure about CORS. And this one here is important. So any API that you use here should always have CORS set to yes, or maybe to unknown. All right. And CORS stands for Cross-Origin Resource Sharing. And without CORS, we cannot access a third-party API from our own code. And so going back here, well, now it's gone. Here it is. So you see, it doesn't need authentication and it uses HTTPS. So this is a good one. And so let's click it, which will take us basically to the documentation page. And now here I'm simply looking for a so-called API endpoint. And so the endpoint is essentially just another name for the URL that we need. So here we have the first URL, and this one is basically for all countries. So if we wanted to get a list of all the countries from this API, we could make an AJAX call to this URL here. Okay, but that's not what we want. Instead, I want to search the API by country name. And so therefore, this here is the URL that I'm going to use. So let's copy it. And I hope that you followed these steps here. And if not, you can, of course, simply paste it here. All right. And I will start with Portugal. But you can, of course, use your own country. So with this, we basically open the request. And now next, we need to also send it. So you see, there are a lot of steps involved when using this way of doing an AJAX call. Okay, and so this will now send off the request to this URL here. Now, in order to get the result, we couldn't simply do maybe something like this. So set some variable simply to this result here. And the reason why we cannot do this is because the result is simply not there yet, right? So this AJAX call that we just send off here is being done in the background while the rest of the code keeps running. And so this is the asynchronous non-blocking behavior that we talked about in the last lecture. So let's get rid of this. And instead, what we need to do is to register a callback on the request object for the load event. So request, and then again our old friend add event listener. And here on the request, we will wait for the load event. So again, here we basically send off the request. And so that request then fetches the data in the background. And then once that is done, it will emit the load event. And so using this event listener, we are waiting for that event. And so as soon as the data arrives, this callback function here will be called. Now, let's then actually log the result to the console. So the this keyword inside of this function is the request, right? So we could also do request, but let's just use the this keyword. And then the response is in the property response text. And again, this property here is of course only going to be set once the data has actually arrived, right? So if we tried to set it out here, then that wouldn't work, of course. So we can still try that just to see request.response text. And so that would be exactly the same as this one. And well, already we have our first data here. So that's great. And as you see, this is the result of our very first AJAX call. So great job. This already worked. And you see that this kind of looks like a bunch of data about Portugal indeed. Now we just need to convert this here to an actual JavaScript object, because what we have here right now is JSON. So remember that JSON is basically just a big string of text. And so what we need to do here is to then convert that. We already did that before, actually. So that's JSON.parse this.response text. So let's then take a look at the data. And by the way, as you see here, of course, the result of request.response text out here is nothing, right? So let's get rid of it. And so indeed, here we have this object with all this data about Portugal. So we have the capital, which is Lisbon. We have the flag even. So basically a link to the image of the flag. And indeed, this is where we're going to get this flag here from. And then all kinds of other stuff, like the location, the population, region, and so on and so forth. Now you see that this is actually an array containing one object. And so let's quickly destructure that like this. So remember, that would be the same thing as doing this, right? But of course, destructuring is a lot more beautiful. And so now we got immediately the object here. Great. And now we can actually build that card component. And so let's copy the HTML here from this comment. So open the index.html file, get the HTML from there, and then we can create a template literal that we then have to fill up. Here I'm of course missing the name, and as always I'm calling it HTML. And so now all we have to do is to replace this data. So let's open it to see what we actually have. So here we are actually starting with the image. So we need a source, and of course that source can be any URL. It doesn't have to be a local image that we have on our computer. And so the one we will use is this one here. And so that is at data.flag. Next up, this is where the actual name of the country goes. So data dot and where, yeah. So down here is the name. Then here I also want the region. So that would be Europe in this case. And so this is the one. So that's data dot region. And then finally, we also want some information about the population, language, and currency. And all of that is present here in this data. So that's at data.population. And so this here is basically 10 million. So we don't want to display this entire number. So let's just round it to 10.3 or 10.4 million. So the way we can do that is to convert this first to a number. So as always, I'm just using plus for that. Then divide it by 1,000,000. So yeah, that's 1,000,000. And then let's round this value finally. So this is a number, and so on a number we can call 2 fixed with 1 decimal place. Next up, language. So I'm doing this pretty fast because here we are basically just practicing what we already know, right? So again, this one is for languages, and so let's see. So languages is basically an array. Oh, now I clicked, and so now it's gone. So let me just put something else here for now, because this was causing the error. So let's see. In languages, we have multiple here, as you see. And so what we want is simply the first element of the languages and then the name. And the same is actually going to happen with the currencies. So we also have an array of the currencies, and then we want the name of the first one. So again, we want data.languages, the first element, and from there we want to take the name, and the same with the currencies. Currencies. All right. And that should be it. And now all we have to do is to then actually insert this HTML into our page. So I actually already have it here selected, but just to make it complete, let me show it to you. So we have this countries element here, and so that's what I call the countries container. And so here we want country.insert adjacent HTML before end, and then the HTML that we just created. Now finally, we also need to set the style of this container to opacity 1. So let me show you that one also in the code. So I set the opacity of the countries container here to 0. And so now we set it to 1 so that we can then see a nice animation, which is going to be triggered by this transition. Okay. First, let's give us some space so we can then actually see it. And so, as I just said, we need to say countries container dot style dot opacity and set it to 1. And now as I save it, the data should appear, and it does. So that's amazing, right? And it looks just like here in our demo. So that's fantastic. I really love it when it works just like this. So getting data from some third-party API really feels like magic to me. Now let's actually reuse the same code here to create an element like this for multiple countries. And so what I'm going to do is to put all of this into a function. Let's call it getCountryData. And so this one will take a string as an input of a country. Okay, so the curly brace down here. And then here, instead of hard coding Portugal, we will use that country that we get as an input. All right, country. And now down here, we can then call this function get country data Portugal. So let's see. And yep, that worked just the same. And now let's try another one. So let's try the United States of America, just like I had it in my demo. And here we go. So now we have data about 2 countries. And by calling these functions here twice, we will basically have 2 AJAX calls happening at the same time. So in parallel, so to say. And if we reload this page here a couple of times, then they might appear in a different order. And the reason for that is basically that the data arrives at a slightly different time each time that we're loading the page. And so, in fact, this really shows the non-blocking behavior in action. So as we call get country data here with Portugal for the very first time, it sends off this request, and then JavaScript moves on in the code right away. And so it goes right here to this next line, and this of course fires off another AJAX call immediately, way before the data of Portugal has actually arrived. So again, we will have 2 AJAX calls happening at the same time, and so whatever one arrives first will then fire the load event first. And so if the first one is the AJAX call for the USA, well, then the first element that's going to be printed here will of course be the one from the USA. And only after that the data for Portugal arrives, and then this callback function here is called with the data of Portugal. And of course the same would be true no matter how other requests we would fire off here. Let's say Germany here. And so now we actually got the data in the same order, but so now it's actually completely different. And so this confirms what I just explained before. Now, if we actually wanted these requests to be made in a specific, like predefined order, then we would basically have to chain the requests, which means to make the second request only after the first request has finished. And that's actually what we're going to do in the next lecture, so that I can show you something that we developers call callback hell. If you want to go really deep and really understand how requests and responses work on the web, then this video is for you. So this is basically a high-level overview of how the web actually works behind the scenes in regard to requests and responses. Now, this knowledge is not required though for moving on in the course, and that's why I marked this video as optional. So you can safely skip it if you want to move on more quickly, but if you're interested, then just keep watching. So this is the diagram that we already saw when we first talked about AJAX calls. So just to recap, whenever we try to access a web server, the browser, which is the client, sends a request to the server, and the server will then send back a response. And that response contains the data or the web page that we requested. And that's right, this process works the exact same way, no matter if we're accessing an entire web page or just some data from a web API. And this whole process actually has a name, and it's called the request-response model, or also the client-server architecture. But anyway, let's now dive a bit deeper into this. So let's use the example of the URL that we actually accessed in the last video to get our country data. Now, every URL gets an HTTP or HTTPS, which is for the protocol that will be used on this connection. And we're going to talk about this a bit later in the video. Then we have the domain name, which is restcountries.eu in this case, and also after a slash, we have the so-called resource that we want to access. And in this case, that's /rest/v2, and so on. Now, this domain name restcountries.eu is actually not the real address of the server that we're trying to access. It's really just a nice name that is easy for us to memorize. But what this means is that we need a way of kind of converting the domain name to the real address of the server. And that happens through a so-called DNS. So DNS stands for Domain Name Server, and domain name servers are a special kind of server. So they are basically like the phone books of the internet. So the first step that happens when we access any web server is that the browser makes a request to a DNS, and this special server will then simply match the web address of the URL to the server's real IP address. All right? And actually, this all happens through your internet service provider, but the complete details don't really matter here. What you need to retain from this first part is that the domain is not the real address, and that a DNS will convert the domain to the real IP address. And then, after the real IP address has been sent back to the browser, we can finally call it. So this is how the real address looks like. So it still has the protocol, but then comes the IP address and also the port that we access on the server. And this port number is really just to identify a specific service that's running on a server. So you can think of it like a sub-address. Okay. This port number has nothing to do with the /rest/v2 resource that we want to access. So that resource will actually be sent over in the HTTP request, as we will see in a moment. Okay, and that actually wraps up the first step. So once we have the real IP address, a TCP socket connection is established between the browser and the server. And so they are now finally connected. And this connection is typically kept alive for the entire time that it takes to transfer all files of the website or all data. Now, what are TCP and IP? Well, TCP is the Transmission Control Protocol, and IP is the Internet Protocol. And together, they are communication protocols that define exactly how data travels across the web. They are basically the Internet's fundamental control system. Because, again, they are the ones who set the rules about how data moves on the internet. And don't worry if that sounds confusing, we are actually going to learn a bit more about TCP/IP a bit later in this video. But anyway, now it's time to finally make our request. And the request that we make is an HTTP request, where HTTP stands for Hypertext Transfer Protocol. So after TCP/IP, HTTP is another communication protocol. And by the way, a communication protocol is simply a system of rules that allows two or more parties to communicate. Now, in the case of HTTP, it's just a protocol that allows clients and web servers to communicate. And that works by sending request and response messages from client to server and back. Now, a request message will look something like this. The beginning of the message is the most important part, called the start line, and this one contains the HTTP method that is used in the request, then the request target, and the HTTP version. So about the HTTP methods, there are many available, but the most important ones are GET for simply requesting data, POST for sending data, and PUT and PATCH to basically modify data. So you see that an HTTP request to a server is not only for getting data, but we can also send data. All right. Now, about the request target, this is where the server is told that we want to access the rest/v2/alpha resource in this case. Remember that? So we had this in the URL before, and now it is simply sent as the target in the HTTP request. And so then the server can figure out what to do with it. Now, if this target was empty, so if it was just a slash, basically, then we would be accessing the website's root, which is just restcountries.eu in this example. Then the next part of the request are the request headers, which is just some information that we sent about the request itself. There are tons of standard different headers, like what browser is used to make the request, at what time, the user's language, and many, many more. Now finally, in the case we're sending data to the server, there will also be a request body. And that body will contain the data that we're sending, for example, coming from an HTML form. So that is the HTTP request, and I hope that it makes sense to you. Now, of course, it's not us developers who manually write these HTTP requests, but it's still helpful and valuable that you understand what an HTTP request and also a response look like. Also, I want to mention that there's also HTTPS, as you probably know. And the main difference between HTTP and HTTPS is that HTTPS is encrypted using TLS or SSL, which are yet some more protocols, but I'm not going to bore you with these. But besides that, the logic behind HTTP requests and responses still applies to HTTPS. All right, so our request is formed, and now it hits the server, which will then be working on it until it has our data or web page ready to send back. And once it's ready, it will send it back using, as you can guess, an HTTP response. And the HTTP response message actually looks quite similar to the request. So also with a start line, headers, and a body. Now in this case, the start line has, besides the version, also a status code and a message. And these are used to let the client know whether the request has been successful or failed. For example, 200 means OK. And the status code that everyone knows is 404, which means page not found. So that is where this 404 code that everyone already knew comes from. Okay? Then the response headers are information about the response itself. So just like before, and there are a ton available, and we can also make up our own, actually. And finally, the last part of the response is, again, the body, which is present in most responses. And this body usually contains the JSON data coming back from an API or the HTML of the web page that we requested, or something like that. So we talked in great detail about the most important parts here, which are the HTTP request and the response. But in our imaginary example, we only just did one request to restcountries.eu and got one response back, right? And that's how it's going to work when all we do is to access an API. However, if it's a web page that we're accessing, then there will be many more requests and responses. And that's because when we do the first request, all we get back is just the initial HTML file. That HTML file will then get scanned by the browser for all the assets that it needs in order to build the entire web page, like JavaScript, CSS files, image files, or other assets. And then for each different file, there will be a new HTTP request made to the server. So basically, this entire back and forth between client and server happens for every single file that is included in the web page. However, there can be multiple requests and responses happening at the same time. But the amount is still limited because otherwise the connection would start to slow down. But anyway, when all the files have finally arrived, then the web page can be rendered in the browser according to the HTML, CSS, and JavaScript specifications that you already know. Now, as a final piece of the puzzle, let's talk again about TCP/IP and figure out how this request and response data is actually sent across the web. Okay, so we said before that TCP and IP are the communication protocols that define how data travels across the web. Now, I'm not going to go into a lot of detail here, but here is what you need to know. So first, the job of TCP is to break the requests and responses down into thousands of small chunks called packets before they are sent. Once these small packets arrive at their final destination, TCP will reassemble all the packets into the original request or response. And this is necessary so that each packet can take a different route through the internet. Because this way, the message arrives at the destination as quick as possible, which would not be possible if we sent the entire data simply as a big chunk. So that would be like trying to go through dense traffic with like the biggest bus that you can imagine. So probably not a good idea. Now, as a second part, the job of the IP protocol is to actually send and route these packets through the internet. So it ensures that they arrive at the destination they should go using IP addresses on each packet. Okay, and that's it. That's a broad overview of what really happens behind the scenes of the web. And I hope that you found this information useful and also interesting and not all too confusing. But anyway, now let's go back to our JavaScript and AJAX calls. So in the last lecture, we did a simple AJAX call to fetch data from a country's API. So we created a function for that, and as we called the function multiple times, multiple AJAX calls were made at the same time. So they were basically running in parallel, and we could not control which one finished first. Remember that? However, in this lecture, let's create a sequence of AJAX calls so that the second one runs only after the first one has finished. And here's what we're going to do. So in the country's data here, there is some property of the bordering countries. So you see, this one here has the code ESP, which stands for Spain. And so that's because Spain is a bordering country of Portugal. And so what we will do now is after the first AJAX call is completed, we will get this border, and then based on this code, we will also render the neighboring country right here besides the original country. And so in this case, the second AJAX call really depends on the first one, because the data about neighboring countries is of course a result of the first call. So without the first call, we wouldn't even know which data to fetch in the second call. And so what we need to implement is a sequence of AJAX call. So here I already copied the function from the last lecture, which is still up here. And so let's call this one here now get country and neighbor. Okay, so again we get the country as an input, and then here we do the first AJAX call, and then once the load event is fired, when the data arrives, we then handle that data. And so everything that we have here is still the same. Now, we will do this part here another time. So basically, once the neighboring country arrives, we also will want to render this one. And so let's export this functionality into its own function so that we don't have to copy it later. And this also makes this function a little bit cleaner. So render country is going to be a function which simply takes in some data. And so like this, we don't have to change the variable names in here. Okay. And so now here, let's then actually call that function. So render country with data. And now we get this error here because of course this function no longer exists. So get country and neighbor. So as I save this now, this should look the same as before. And so indeed it does. Okay, But now here, let's actually get the neighbor country. So let's write that. Get neighbor country. And here, actually, let's also do some comments now. So render country 1, let's say. And here I will say AJAX call country 1. So the neighbor country will then be country 2. So the neighbor is going to be data.borders, I believe. So let's just check that here again. And so this is actually an array. And so we will simply render the first element. So in the case of Portugal, there is just one border, but in other countries like Germany, there's like 10 borders or something. So let's just destructure here, basically just take the first element. But of course, there are also countries which have no neighbors at all. So islands, basically. And so for these cases, let's simply make sure that we don't run into any mistakes. And so in that case, we simply return immediately. But of course, if the neighbor does exist, then now we can do the second AJAX call. And so let's copy all of this. And so here, AJAX call 2. And now here, of course, we don't want to use the country, but we want to use the neighbor. But there is one particularity about that, because here the border, so this one here, this country, actually doesn't come with the name of the country, but with this code. Okay? But using our API, we can actually also search by the code. So right here we have that. So right now we are using the name, but as I said, we can also search for the code. And so all we have to change is basically here from name to alpha. So that's alpha here, and then here, the neighbor. All right. Okay. And so now, just like before, we have to then listen for the load event on this new request. And let's call this request 2, because of course we can't do that on the same request that we did here in the beginning. So request 2, add event listener, load, and then our callback function. And so you're starting to see now that the second AJAX call, in the way we are setting it up here, is really dependent on the first one. So that's because basically we are firing off the second AJAX call here in the callback function of the first one, right? So basically inside of this callback function, we are now adding a new event listener for the new request. And so here we now have one callback inside of the other one. All right. And so we will talk about that once we have this code working. But for now, let's actually take a look at the result here. And so that's going to be request, or actually just a this keyword. So this dot response text. So let's see. And indeed, now we got data about Spain. And no matter how many times we reload the page, it will now always appear after Portugal. All right? Because there's no way that this AJAX call here can be made before the one on Portugal. Okay? And so now, well, let's just do the same as we did here. So we don't need this. Let's say data2 should be JSON.parse, and then this. And of course, we need to also destructure it then, logging it to the console. But now we get some error here. So let's just take a look at the result itself without any destructuring. Oh, and so now it works. And the reason for that is that the response of this API is actually no longer an array when we search for the code. So here we have this alpha, remember, and so this time we are searching for country codes and not for country names. And so the country codes are unique, and so therefore they can always just be one result. And so that's the reason why no array is returned. And probably it says here so in the documentation. Well, it doesn't say so, but if we would have just simply inspected the response here, then we would have understood that as well. But anyway, now it worked, and so let's now render this country here as well. So data2, and now let's wait, and there it is. Great. Now actually I created a special class here for the neighboring country so that it appears a little bit smaller. And so when it is the neighbor, we want to attach some class here to the country. And so let's pass that class in. So let's say class name, and by default we set it to nothing. So here we will just add it to the string like this. And now when it is a neighbor, we can just pass in neighbor like this. Give it a save. And yeah, so that looks a bit nicer. We get the information that this is a neighbor country. And so now let's try this, for example, for the USA as well. But now I just want to do one at a time. So here we should probably get Mexico or Canada. And indeed, here it is. Here is Canada, the neighboring country of the US. And so one more time, this second AJAX call would not have been possible without the first one. Because otherwise, how would we know that the second country here needed to be Canada? Okay, so again, we have one AJAX call here that depends on another one. And so what we have here is one callback function inside of another one. So you see, here we attach the first callback function, and then inside of that, we have yet another one. So in other words, here we have nested callbacks. But now imagine that we wanted to do more requests in sequence, like the neighbor of the neighbor of the neighbor, and like 10 times over. So in that case, we would end up with callbacks inside of callbacks, like 10 times. And actually, for that kind of structure and for that kind of behavior, we have a special name. And that special name is callback hell. So basically, callback hell is when we have a lot of nested callbacks in order to execute asynchronous tasks in sequence. And in fact, this happens for all asynchronous tasks which are handled by callbacks, and not just AJAX calls. So, for example, let's say we have a setTimeout function, and then here we want to log something to the console like 1 second passed, but then also we want to start another timeout. Let's just set 1000 here. So let's copy this one here. And so, as I just said, let's say that here we wanted to start a new timer after the first timer has finished. So here we can say 2 seconds passed, and we can even add another one. So never mind about what just happened in the console. And here, why not add yet another one? All right. And so now they should appear like 1, 2, 3, 4. And so here too, of course, we have callback hell. And in fact, callback hell is pretty easy to identify by this triangular shape that is formed here. You see that? And also the same is starting to appear here. Right? So if we had more callbacks in here, then we would start to see a lot more indentation here. And then this triangular shape would also appear there. Now, the problem with callback hell is that it makes our code look very messy. But even more important, it makes our code hard to maintain and very difficult to understand and to reason about. And code that is hard to understand and difficult to reason about will have more bugs and is just worse code. So this is a great rule that you should always remember and keep in mind. So again, the rule is that code that's hard to understand is basically bad code because it will have more bugs. Because the harder it is to understand code and to reason about the code, the more difficult it will be to add new features and to add more functionality to the application. But anyway, given all these problems with callback hell, we of course need a way to solve callback hell. And fortunately for us, since ES6, there is actually a way of escaping callback hell by using something called promises. And so let's now take the next step in our journey of asynchronous JavaScript, which is to learn all about promises. In the last video, we got a glimpse into callback hell, and it was not pretty. So in this lecture, let's learn about a modern JavaScript feature called promises, so that we can escape callback hell. However, before we learn about promises, we should actually see one. And so let's now replace the old XML HTTP request function with the modern way of making AJAX calls. And that is by using the fetch API. So let me go up here to our first function, and I will just copy all of this just to see how it used to work and how we can do it now. Okay, so this is how we used to do it, and now all we need to do is to call fetch, and then with our URL, so let's just grab that part and then specify Portugal, and that's actually it. All we have to do now is to store the result into a variable, and let's still call it request here. Now there are actually some more options that we can specify here in the fetch function if we'd like, but to make a simple GET request like this one, all we really need is to pass in the URL, and that's it. So for more complex AJAX calls, the fetch function can take in like an object of options as well. But again, for now, we don't need that. But anyway, let's now give it a save. And well, we should also log the request to the console to see what happens. And so you see that the fetch function immediately returned a promise here. So as soon as we started the request, we stored the result of that into the request variable. And then as we logged it, we immediately got the promise here. So let's do that again. And again, right away, we got something called promise. And here it says pending. So if we open that up, then here it says fulfilled. And we also have like a value here. But I'm not going to go into full detail just yet. So what matters here is that now we actually have a promise. And so this promise is right now stored in this request variable. But now, what exactly is a promise and what can we do with it? Well, let's find out. So the formal definition of a promise is that it's an object that is used basically as a placeholder for the future result of an asynchronous operation. And if that sounds weird to you, we can also say that a promise is like a container for an asynchronously delivered value. Or even less formal, let's say that a promise is a container for a future value. So there you go. That's the most distilled down definition of what a promise is. So a container or a placeholder for a future value. And a perfect example of a future value is the response coming from an AJAX call. So when we start the AJAX call, there is no value yet, but we know that there will be some value in the future. And so we can use a promise to handle this future value. And don't worry, this will really make sense once we go back to code. But to understand this concept even better, I like to use the analogy of a lottery ticket. So a promise is just like a lottery ticket. So when I buy a lottery ticket, essentially I buy the promise that I will receive some amount of money in the future if I guess the correct outcome, right? So I buy the ticket now with the prospect of winning money in the future, and the lottery draw, which determines if I get the money or not, happens asynchronously. So of course, I don't have to drop everything and keep waiting until the lottery draw happens, right? Now, in case I did get the correct outcome, then I will receive my money, because I have my lottery ticket, which is the promise that I bought. Now, what's the big advantage of using promises? Well, there are two of them actually. First, by using promises, we no longer need to rely on events and callback functions to handle asynchronous results. Events and callback functions can sometimes cause unpredictable results, and so this is a big win already. But even better, with promises, we can chain promises for a sequence of asynchronous operations instead of nesting like we did in the last video. And with this, we can finally escape callback hell, which was our initial goal all along. And by the way, promises are an ES6 feature, so they became available in JavaScript in 2015. And so by now, they are widely used by everyone. Now, since promises work with asynchronous operations, they are time sensitive, so they change over time, and so promises can be in different states. And this is what we call the life cycle of a promise. So in the very beginning, we say that the promise is pending. And so this is before any value resulting from the asynchronous task is available. Now, during this time, the asynchronous task is still doing its work in the background. Then, when the task finally finishes, we say that the promise is settled. And there are two different types of settled promises, and that's fulfilled promises and rejected promises. So a fulfilled promise is a promise that has successfully resulted in a value just as we expected. For example, when we use a promise to fetch data from an API, a fulfilled promise successfully got that data, and it's now available to being used. On the other hand, a rejected promise means that there has been an error during the asynchronous task. In the example of fetching data from an API, an error would be, for example, when the user is offline and can't connect to the API server. Now, going back to the analogy of our lottery ticket, the lottery draw is basically the asynchronous task which determines the result. Then, once the result is available, the ticket would be settled. Then, if we guessed the correct outcome, the lottery ticket would be fulfilled and we get our money. However, if we guessed wrong, then the ticket basically gets rejected and all we did was waste our money. Now, these different states are very important to understand because when we use promises in our code, we will be able to handle these different states in order to do something as a result of either a successful promise or a rejected one. Another important thing about promises is that a promise is only settled once, and so from there, the state will remain unchanged forever. So the promise was either fulfilled or rejected, but it's impossible to change that state. Now, these different states that I showed you here are relevant and useful when we use a promise to get a result, which is called to consume a promise. So we consume a promise when we already have a promise. For example, the promise that was returned from the fetch function right at the beginning of this video. Remember? But in order for a promise to exist in the first place, it must first be built. So it must be created. In the case of the fetch API, it's the fetch function that builds the promise and returns it for us to consume. So in this case, we don't have to build the promise ourselves in order to consume it. Now, most of the time, we will actually just consume promises, which is also the easier and more useful part. And so that's what we will do in the next couple of videos. But sometimes we also need to build a promise and not just consume it. And of course, we will also learn how to do that a bit later. All right. And so now let's actually start using promises in the next video. In this lecture, we will learn how to consume a promise. And in this case, we will consume the promise that was returned by the fetch function. So let's now implement the getCountryData function from the very first lecture, but of course this one using a promise. So getCountryData, and so again, here we pass in a country, and then here we will want this fetch function, and here again with the country then. So making this a template, literal again, and then country. And as we already know, calling the fetch function like this will then immediately return a promise, so as soon as we start the request. And in the beginning, this promise is of course still pending, because the asynchronous task of getting the data is still running in the background. So just as we learned in the last lecture. Now, of course, at a certain point, the promise will then be settled, and either in a fulfilled or in a rejected state. But for now, let's assume success. So assume that the promise will be fulfilled and that we have a value available to work with. And so to handle this fulfilled state, we can use the then method that is available on all promises. So just like this. So again, this here will return a promise, and on all promises we can call the then method. Now into the then method, we need to pass a callback function that we want to be executed as soon as the promise is actually fulfilled. So as soon as the result is available. So a function, and then this function will actually receive one argument once it's called by JavaScript. And that argument is the resulting value of the fulfilled promise. So let me call it response here, because this is the response of an AJAX call in this case. All right, and that's it. So this is how we actually handle a fulfilled promise. But now let's actually do something with the response here. And as always, I will start by logging it to the console. But of course, we also need to call this function here. All right. And so here we now get the response indeed. And even the type of this object is actually called response. Let's just get rid of this here for a second. So we have a cleaner output here. All right. And so here indeed we have a couple of things about the response itself. For example, here the status code or the headers. And so if you watch the lecture about how the web actually works behind the scenes, then this kind of data here will be familiar to you. But anyway, what we're actually interested in is the data itself. And so that data is in the response body here. So let's click here just to see. And as we see, the body is basically this readable stream. All right. And so actually we cannot yet really look at the data here. So in order to be able to actually read this data from the body, we need to call the JSON method on the response. Okay. So JSON is a method that is available on all responses of the fetch method. So what I mean is this. So response.json. So again, the JSON method here is a method that is available on all the response objects that is coming from the fetch function. So all of the resolved values. And indeed, this response here is in fact a resolved value. And so therefore, it does have the JSON method attached to it. Now the problem here is that this JSON function itself is actually also an asynchronous function. And so what that means is that it will also return a new promise. And that's all a bit confusing And I really don't know why it was implemented like this, but this is just how it works. So anyway, what we need to do now here is to actually return this promise from here. Okay, because remember, this here will be a new promise. Okay, and so now we need to handle that promise as well. All right, and so the way we do that is to then call another then right here. So we need another callback function. This time let's call it data. And for now, let's log it here to the console. And let's give it a save just to see if it worked. And yeah, here it is. So here we are back to having the same data that we already had before, but this time using a promise, or actually two promises. So let's recap what happened here. And the first part here, I think, is pretty straightforward, which is this fetch function here returning a promise, and then we handle that promise using the then method, right? But then to actually read the data from the response, we need to call the JSON method on that response object. Now this itself will also return a promise. And so if we then return that promise from this method, then basically all of this becomes a new promise itself. And so since this is a promise, we can then again call the then method on that. And so then again, we have a callback. And this time we get access to the data because the resolved value of this promise here is going to be the data itself. So basically the data that we're looking for, which is then this one here, right? And so now all we have to do is render country of data 0. Okay. And so here it is. So we just did the same thing as before, but using promises. And if we didn't have all of these console.logs here, we could actually simplify this a lot. So let me just copy it so that we get to keep this version as well. But then we can create a highly simplified version as well. So getting rid of this console.log and this one here. And then we can transform these here to arrow functions. And so this is going to work because this one will now implicitly return this result here. So this promise. And so then on that promise, we can call another then method. All I'm doing here is to simplify the code that we already had before. And you see that indeed it still works. So what do you think looks cleaner and nicer? Is it this code here using fetch and promises, or is it this function that we wrote right in the beginning with all of this weird stuff that we have going on here, and with this event and listening for the event, and even worse here with all these nested callbacks? So I hope that you agree that this here is actually a lot nicer. But besides being nicer, the code is also easier to read and to reason about. And as I mentioned before, that in itself is very important. So it's very easy to understand that this fetches something, and then we get a response, which will be transformed to JSON, and then we take that data and render the country to the DOM. Okay, so this almost reads like English sentences, and that's very helpful to understand the code now and also in the future. Now, just to finish, you might be thinking, well, we're still using callbacks here, right? And that is actually true. So promises do not get rid of callbacks, but they do in fact get rid of callback hell. So even if this doesn't look like a big change for now, it will look like a change after we add the functionality of loading the neighbor country like we did in the previous lecture. And so actually, let's go do that now in the next lecture. Let's now learn how to chain promises in order to also render the neighboring country of the initial country that we give to the function. And actually, we already have a small chain of promises because of this JSON function. And so here, these two thens called in sequence are basically already a small chain. But anyway, in this lecture, we will now take chaining to a new level and actually chain together two sequential AJAX calls. So just like before, we first get data about the country, and so that's the part that we already have here. But then we also want to get the data about the neighboring country. And so again, the second AJAX call depends on the data from the first call, and so they need to be done in sequence. So let's simply modify what we already have here. And so the second AJAX call basically needs to happen here in this then handler. So as soon as we get the data, then we need to get the neighbor country and do the AJAX call for that one as well. So let's get the neighbor. And we already know that it is at data 0, at borders, and then also the first one. And just like before, let's say if there is no neighbor, then return immediately. And actually this is not going to work, but never mind about this for now. So we will talk about error handling actually in the next video. Now here there is some kind of problem. We're missing the closing parenthesis here. All right. But now there is no error. And so let's do the second AJAX call. And let me just get the URL from up here. So that's this one. Okay. And so we use again fetch and then the URL. So let's call it country 2 and here country 1. All right. Now for now, this is not going to do anything because what we need to do now is to actually return this new promise. Because then when we do that, we will be able to chain a new then method on the result of this then method. All right. So that's a bit similar to what we did here with the JSON method, which remember also returned a promise. And so we return all of that promise here, and then we can chain a new then method onto that as well. Now in the last lecture, I actually oversimplified how things really work. So actually, the then method always returns a promise, no matter if we actually return anything or not. But if we do return a value, then that value will become the fulfillment value of the returned promise. So let me actually show that to you. So instead of returning this for now, let me just return 23. And so then when I chain a new then method here, let's say data, and then let's alert that data. Let's see. And then indeed we get 23. And so again, that happens because whatever we return from this promise here will become the fulfilled value of the promise. Okay? So again, this here returns a promise, and so we can handle it using the then method. And the fulfilled value, so the success value basically of the promise, will be the value that we return from this then method, right? And so that is this 23 here. And so therefore, in the next then method, then the data here will be 23. And of course, this here must be 23, otherwise we cannot see that in effect. But yeah, so it is 23 because this value is 23. So again, this data that we receive here as an input to this function is the fulfilled value of the promise that we're handling. And so again, that's this value 23 that we are returning from this then method here. Okay, but anyway, of course, the same is true for promises. And so by doing this, so by returning this promise here, then the fulfilled value of the next then method will be the fulfilled value of this previous promise. so of this one. Okay, so I know that sounds confusing, but what you need to understand is that basically this then method here returns a new promise, and here we can then one more time handle the success value of that promise. So one more time, I'm calling this one now a response, because here we are dealing with the fulfilled value of a fetch promise. And so that is a response. And so therefore I like to call it like that. And so here, one more time, we need to call the JSON method. And that is pretty annoying, but that's just how we have to do it. And so here again, the fulfilled value of the promise will become that body. So the data that is stored in the body. And then we can again handle that. So data like this, and then render country with data. And then here again, we pass in that CSS class for the neighbor. Okay, and that should already be it. And indeed, here we go. And if we try something else, let's say Germany, let's see what country we get. And it's Austria. Okay, but anyway, let's just put it back to this one here. And yeah, that's actually it already. So as you can see, promises really allow us to handle these complex asynchronous operations with as many steps as we want. So right now we have 4 steps here even, but of course we could extend this as much as we want. So even if we wanted the neighbor of the neighbor of the neighbor, like 10 countries, we could easily do this by chaining all these promises one after another, and all without the callback hell. So here, instead of the callback hell, we have what we call a flat chain of promises. And this one is, again, very easy to understand and to read. So as a conclusion to this video and the previous one, promises really are an incredibly powerful and elegant solution to handle asynchronous code. Now, just to finish, I want to show you a pretty common mistake that many beginners make, which is to basically chain this then method directly onto a new nested promise. So, as we know, this one immediately returns a promise, and so many beginners basically do this instead. Let me show it to you here. So instead of returning the new promise, they then chain the then method right here. So right inside of this then method. Now this actually does still work, but then we are in fact back to callback hell. Because now indeed we have one callback function here defined inside of another one. So inside of this enclosing callback function. Okay? And so of course, that's exactly what we're trying to avoid. And so don't do this. So always return the promise and then handle it outside by simply continuing the chain like this. All right, but I hope that this was already pretty obvious anyway from all the explanations that I gave you throughout this lecture and the previous one. But anyway, let's now move on and actually handle errors, because that is also a pretty common scenario when we work with promises, and especially with AJAX calls. So until now, we have always assumed that everything went well with our AJAX calls, so we never handled any errors. However, an important part of web development is to actually handle errors, because it's very common that errors happen in web applications. And so in this lecture, let's talk about how to handle errors in promises. And to start, remember that a promise in which an error happened is a rejected promise. And so in this video, we're going to learn how to handle promise rejections. Now, actually, the only way in which the fetch promise rejects is when the user loses his internet connection. And so for now, that's going to be the only error that we will handle here. Now, to simulate losing the internet connection, we can go here to network, and then we can basically change the speed here to offline. However, when we then reload the page, then basically everything will disappear. And so that's not really what we want. We want to simulate that the page was first still loaded, but then as the user does the request without internet, then we want to see the error happening. And so let's set it back to online. And so now what we want to do is to basically only call this function here whenever the user clicks on a button. And so that will then make it easier for us to simulate losing the internet connection. So here in the HTML, we already have a button. So let's comment this one out. And then in the script, I believe, so we already have it here selected as this btn. And so all we will do now is btn.addEventListener, click, and then here function, and just like this. All right. So just to see what happens here. So indeed, that works just fine. But now watch what happens when we set ourselves offline. Let's go back to the console. And so now when we do the request, then we get these errors here. So first, this one here. But the one that's most important is that we now have an on-caught promise. And so because we have failed to fetch. And so at this point, for the first time, the promise that's returned from the fetch function was actually rejected. And so let's now handle that rejection. Now there are two ways of handling rejections. And the first one is to pass a second callback function into the then method. So the first callback function here is always going to be called for the fulfilled promise. So for a successful one. But we can also pass in a second callback, which will be called when the promise was rejected. So let's do that. And this callback function will be called with an argument, which is basically the error itself. And so let's simply alert the error. All right. So let's try that. Oh, and now we are back to having no internet. So we first need to do everything normally. So load the page. Now we lose the connection. And now we do the request. And so now actually we handled the error by displaying this alert window. And the error that we saw previously down here is now gone. So now, in fact, we no longer have this uncaught error down here because we did actually catch the error right here. So handling the error is also called catching the error. And so again, that's the reason why this error that we had here before disappeared. So it said uncaught error, but again, now we are actually catching it here. And so with this, we are now handling the error that might occur in this promise here. Okay. Now in this case, there are then no more errors because basically the chain stops here when this error happens and when it's handled right here. But now what if there was actually no error in this fetch promise here? So basically, what if this fetch promise was actually fulfilled, but then the second one here was rejected? Well, then we would also have to catch an error here. So we would have to come here, get this function and paste it here, and also handle the error right here. However, that is a little bit annoying. And so in fact, there is a better way of basically handling all these errors globally just in one central place. So instead of all of these callback functions here, let's just delete them. Okay, so this is a lot nicer just having one callback in the then. And then instead, we can handle all the errors no matter where they appear in the chain right at the end of the chain by adding a catch method. And then here we can actually use the same callback function because the callback function here will also be called with the error object that occurred. And so then we can handle it in some way. All right. So again, this catch method here at the end of the chain will basically catch any errors that occur in any place in this whole promise chain, and no matter where that is. So errors basically propagate down the chain until they are caught. And only if they're not caught anywhere, then we get that uncaught error that we saw right in the beginning. All right, so let's now try this again, and we will have to put back the internet, reload the page, get back offline, and indeed, we get the same error now here. So the same alert window that we had before. Now instead of having that annoying alert window, let's just log the error to the console and create some string here. So error, and then let's just add some emojis so that we know exactly which errors were printed by ourselves. Well, let's add a couple of them here. And in fact, we can actually also style this one with console.error. Remember? I think I showed you this one at some point in the beginning of the course. But anyway, usually simply logging the error to the console is not enough in a real application with a real user interface. And so instead of just logging something to the console, let's also display an error message for the user to see. And so that's then a more real use case of this catch block. All right, so I'm adding a new block here. So we still want to, of course, log the error to the console. But besides that, let's actually now create a function that will also render some kind of error. Okay, so let's do that outside here. And I'm calling it render error. So this is a function, and it can take in a message. Just call it like this. And just like the country elements, we want to attach this to country's container, and then insert adjacent. And this time not HTML, but insert adjacent text. So this is a new one, but basically it does the same thing as insert adjacent HTML, but simply with text. So it doesn't create any new HTML elements. Okay, and then besides that, remember, we always have to set the opacity back to 1. So just as we did before in the render countries function, because otherwise this container is not even going to be visible. And actually, let's put this function right at the very top of the file together with the render country function. So just like this. Okay, so again, in both cases, in order to actually see the container, we set the opacity to 1. Okay, and so now here, let's use that. Render, so not country, of course, error. Let's say something went wrong. Then here we can use our emoji again. Why not? And then here, let's again print the error. And actually, this error that is generated here is a real JavaScript object. So we can create errors in JavaScript with a constructor, for example, just like a map or a set. And any error in JavaScript that was created like this contains the message property. So we can use that here to basically only print the message of that error and not the whole object itself. And we will actually learn more about the built-in error object of JavaScript in the next video. Now to try this, we need to again get ourselves online. Then offline, check the console. And indeed, we get our custom error down here, visible by the emojis, and then our own message here for the user. Now it's not super pretty, but that's not the point here. And as you see, indeed, this here is simply the error.message. while down here we have the entire error. So that includes the type error, and even it includes this so-called stack trace. So it shows us exactly where the error comes from. All right, and so that's how we handle errors happening in promises in any then handler. So basically handling any promise rejection, no matter where it happens in the chain. Now, just to finish, there is one more quick method that I want to show you, and that is also available on all promises. So besides then and catch, there is also the finally method. So let's add a finally here. Finally, and then the callback function that we define here will always be called whatever happens with the promise. So no matter if the promise is fulfilled or rejected, this callback function that we define here is going to be called always. So that's the difference between the other two. So the then method is only called when the promise is fulfilled, while this one is only called while the promise is rejected. Now, the finally method is not always useful, but sometimes it actually is. So we use this method for something that always needs to happen, no matter the result of the promise. And one good example of that is to hide a loading spinner, like these rotating circles that you see everywhere in web applications when you load some data. So these applications show a spinner when an asynchronous operation starts, and then hide it once the operation completes. And that happens no matter if the operation was successfully or not. And so for that, the finally method is perfect. And in our case, what we always need to do is to fade in the container. So basically, this part here always happens no matter what, right? So no matter if we render the country in the case of success, or if we render the error in case of an error, no matter what, we always need to do this. And so let's take this out of here. So I'm copying it here and deactivating this in both cases. And then let's put it here into the finally handler. Okay. And now we no longer need the offline. So let's just reload, put it here. And yeah, that works beautifully. Just notice that this actually works because catch itself also returns a promise. So that's the only way why this here can work. So of course, this only works on promises. And so, yeah, again, this can only work if catch itself also returns a promise. All right. Now let's try to simulate another error so that I can show you what we need to do next. So let's say that we're trying to search for a country that simply doesn't exist. And so our API is not going to find any result for that. Let's say just this. So let's see. And well, we get this weird error that we cannot read property flag of undefined in line 152. No, so basically it's coming from this place. But of course, then in our stack trace, we can see where exactly it's coming from. So it's coming from get country data. Well, in this case, it's not that helpful, but sometimes inspecting this stack trace can be helpful indeed. So anyway, this error here is weird, and it doesn't really reflect the true error, which is simply that our API cannot find any country with this name. So the true error is of course not that we cannot read flag of undefined, but in fact, it is that our API cannot find any country. And so that's reflected here with the status code of 404. However, as I said in the beginning, the fetch promise only rejects when there is no internet connection. But with a 404 error like this, which is not a real error, but well, it kind of is. But anyway, with this 404, the fetch promise will still get fulfilled. So there is no rejection, and so our catch handler cannot pick up on this error. It does pick up on this other error, so this one here, but that's not the one that we actually want to handle. In this case, we really want to tell the user that no country was found with this name. And so that is what we will do in the next lecture, so that this one doesn't become all too long. So in this lecture, we're going to fix the request 404 error that we saw happening in the last lecture. And so as we saw in the last video, the problem here is that during the fetch, there was a 404 error, which is because our API couldn't find any country with this name. But still, even though there was obviously a big problem with this request, the fetch function still did not reject in this case. And by the way, many people, and that includes myself, think that in this case, the promise should actually be rejected right away. But again, it just doesn't, and so we will have to do it manually. So to see what happens here, let's go back to this first then handler here, which gets access to the response immediately, so without even the data. So here I'm adding back a block, and let's take a look at the response here. And also, since we added back the block, we now need to return this explicitly. So again, for now, we are just taking a look at the response object here. And so here it is. And so right here, you can see that the OK property is set to false. And so the reason for that is, of course, this status code 404. Now, when the request goes well, and so that's what's going to happen when I click here. So then if we take a look at the response, OK is true, and that's because status is 200. And so 200 literally stands for OK. So we can now use the fact that this response has the OK property set to false to basically reject the promise ourselves manually. All right? So we can do that by creating a new error. So we can say if there is no response.ok, or in other words, if response.ok is false, then we write throw new error, and then here we can define an error message. So let's write a very logical message here, which is country not found. So this is the real error message that we want to see here, and of course not this one here with cannot read property of undefined. And here we can then also take the status code and display it as well. So this 404 in this case. Let's just wrap it here into parentheses. And OK. So this is something that we never did before. So let's analyze what happens here. So we create the new error by using, again, this constructor function basically. And then we pass in a message, which is going to be the error message. Then we use the throw keyword here, which will immediately terminate the current function, so just like return does it. Now, the effect of creating and throwing an error in any of these then methods is that the promise will immediately reject. So basically, the promise returned by this then handler here will be a rejected promise. And that rejection will then propagate all the way down to the catch handler, which we already have set up here. And so now if we would try to reload this, and actually let's do that. So now this error message that we created here, so that's country not found 404. So exactly this is exactly the rejection that we created here by creating this new error. All right. So again, any error that happens in any of the callback functions here, so in any then handler, will immediately terminate that then handler and will propagate down to the catch method here. And then in there, we handle that error. And so therefore, that's why we then see the error here displayed. So that error.message is exactly that message that we pass into the error here. And in fact, the same is true for any other error. So before we had this, the error that we saw was this one here. And that's because somewhere in the render country function, we are trying to read the flag from the data that we received. But the data that we received did not contain this flag. And so therefore it created this error, and then that error caused the rejection of the promise, which was then one more time handled down here. Okay? So again, any error will cause any promise to reject. But here we are simply creating our own error to basically reject the promise on purpose so that we can then handle that error down here in the chain, so in this catch method. All right, but now you might be wondering, why should we even bother handle all these errors? Isn't that just a bunch of work and a waste of time? Well, first, handling these errors is the only way in which we can actually display an error message like this on the screen for the user. But even more important, it's just a really bad practice to leave these rejected promises like hanging around without handling them. So don't do that. Always use catch, and if necessary, you can also use finally. Okay. And now, again, what if there was no error here in this promise? So if we got no problem in this one here, but then we got a problem in the second fetch. So let's say that we don't do this, and so we have a reasonable country, which is Portugal, when we click on the button. But then here, let's say that the neighbor is not this one, but this country code, which I'm sure does not exist. And so now there is going to be a rejection in this promise, right? So we get another error here. In this case, it's a 400 error, which means something else. But in any case, the error is not handled. So we now need to go ahead and copy this code here also into this then handler. Let's actually do that, even though we know it's a bad practice and we need to fix this later. Okay. And so now we get the error message that we want. So again, country not found, and this time with the code 400. But now, of course, we have all this duplicate code here. So we shouldn't have this here. And in fact, even all of this is kind of repetitive. It's really, if you think about it, the same code as this one. And so now I think that it's a good time to actually create ourselves a really nice helper function. And this helper function will wrap up the fetch, the error handling, and also the conversion to JSON. Because in my opinion, it's really a bit cumbersome to having to do all these steps all the time. So having the fetch and then having to convert that response to JSON and only then being able to handle it, right? So instead, we will basically encapsulate all of this here into one nice function. So let's do that. And I'm going to call it getJSON. So basically, because it gets data and it immediately converts it to JSON. Now, what do we need here as parameters? Well, for sure, we need the URL. And so for now, that's okay here. So let's get, or actually we can just write it. So what we want here is fetch, and then the URL that we pass into the function. And then on that, we want to call then, and then basically with all of this. So let's grab it here. And of course, we are missing the callback function itself here. So that should end somewhere here. And, well, apparently it doesn't. Maybe like this. And yes, that's correct. All right. Now, in order to actually make this function here really generic, we do not want to hardcode the error message, but instead we want to pass the message in. So let's say error message, and we can set a nice default value. So let's say something went wrong, which again is very generic. And so here inside of this, we then want the error message that we pass in and along with response.status. Okay, and now all we need to do is to return all of this. And so like this getJSON function will actually return a promise. And so this is then just like any other promise that we can call here in our chain and basically replace all of this. So just so we can keep this code, I'm going to copy it. And so you can then keep this code here basically as a reference for when you need to study it again. Okay, but again, I will now go ahead and take everything that we just nicely encapsulated into our getJSON function and simply replace this. So getJSON, and then the URL is this one, and the error message is country not found. All right, and so now we can take away all of this. So this is already in our getJSON function, and so we don't need this. All right, and now the same down here. Instead of fetch, we can get JSON, and then we don't need this then here. And again, the error message is country not found. Okay, and so let's get rid of this. All right, so let's check here. And indeed, we get, again, country not found with code 400 because of this one. So that's working great, but there's still one more thing that we need to do, which is to handle the fact that sometimes there might be no neighbor. So right now, what we're doing here when there is no neighbor is to simply return. But as I mentioned before, that doesn't really do anything. So let me just try here a country that has no neighbors. So let's say Australia, because that is an island. And so here again, we get cannot read property flag of undefined. And so that is happening because it is trying to render a country that doesn't exist. Okay. So again, it's because of this neighbor. And just to make sure, to illustrate my point here, you see that the neighbor is indeed undefined. And so what we want to do here is to simply, just like before, throw a new error that will then get caught down here in our catch handler. Right? So throw new error, no neighbor found. And that's a lot better. So now this is a real error message that actually makes sense to the user. Of course, this could be all a bit better, but this is just a demonstration anyway. But I think that it nicely demonstrates how we can create a real error message that does actually make sense. And again, that is super important for any user interface that you're building. Because in web applications like this very small one, errors will happen. That is just guaranteed. And so your application needs to be ready and needs to be prepared for that. All right, so let's now quickly recap here. And I think that the big takeaway from this lecture is that whenever we want to create some error that we want to handle down here in the catch handler, all we need to do is to throw and create a new error just like we did here. And of course, we can do that for multiple reasons. So in this case here, we did it simply because in the situation, no neighbor can be found. And so that is a good reason to display an error message on the user interface. And since we do that down here in our error handler, the best way of doing that is to indeed throw an error. And remember that this works because throwing an error inside of this callback function of this then method will immediately reject this promise. And so then that rejected promise will travel down the chain until it is eventually caught somewhere. So again, in this case, it is right here in this catch handler. So when working with real applications in the real world, really make sure to keep this technique in mind because it's really important. Welcome to the first coding challenge of this section, and also in a long time actually. And this one is going to be a big one, and so let's get started right away. And in this challenge, you're going to build a function where am I, which then displays a country on the page, but based only on the GPS coordinates that you provide to the function. All right? So instead of providing a real country name like Portugal, all you will provide is coordinates of any place on the world, and based on these coordinates, then a country will be rendered just like we have been doing. All right? And so for that, we are going to use a second API to basically geocode coordinates. And so here are your tasks. So again, create a function where am I, which takes as inputs the latitude and longitude. So coordinates, as you already know, and as always, we have some test data down below. Then the next step, once you got these coordinates, is to do reverse geocoding on these coordinates. And reverse geocoding means to convert coordinates to a meaningful location, for example, a city or a country name. And so the API that we're going to use for that is this one. So go to this URL geocode.xyz, and then here click on API. And so down here, you then have the format of the URL that you need to use in order to do reverse geocoding. All right, so the URL format is simply this one here, but instead of XML, you should use JSON. So that's exactly what we have here. All right, so to do this, you should use the fetch API, of course, and then also promises, just like we have been doing in the last couple of videos. However, do not use the getJSON function that we created previously. So that would be cheating because it would make this whole challenge too easy. Next, once you have the data, take a look at it, and then using the data, print a message like this here to the console. Then chain a catch method to the end of the promise and log any errors that might occur to the console. Then finally, there's one important thing about this API, which is that it only allows you to make 3 requests per second. So if you reload the page really fast, then you will get an error with the code 403. And this is an error with a request. So it's a little bit like the 404 error that we worked on before. Remember? So the fetch function does not reject the promise in this case. And so you basically have to do that manually. And so that is step 5. And so with that, you completed part 1. So part 1 is basically about reverse geocoding. And then in part 2, it's time to use the data that you get from step number 1 to render a country. And so take the relevant attribute from the geocoding API and plug it into the countries API that we have been using. And just like we have been doing, render the country and also catch any errors. And for this one, you can actually even copy the code, so there's no need to type the same code, at least if you're in a hurry. So if you want to write the same code again, of course, that's still great, because that will help your muscle memory to really internalize these concepts. Now, if for any reason, by the time you're watching this course, this API here is no longer working, then please just Google for another reverse geocoding API. So I'm sure there should be another one that you can use. Okay? But anyway, once you have all of this done, then you should test your function with these 3 test data coordinates. So hopefully you can complete this challenge and have some fun along the way. So I designed this one to one more time be fun for you. So go have some fun now, and I see you back here once you're ready. All right, so here I am back, and here goes my solution. So where am I is the function that we're gonna create, and that you hopefully created yourself. And so if your code works perfectly, then there's actually not even a need to watch this video probably to the end. But anyway, let's now take this URL format and then do a fetch request to this URL. So fetch, here let's use a template string, because now here we need to plug in the latitude. And then here after the comma, we need the longitude. All right, then on this we call the then method, and here we get the response. Let's just call it res for now, and then immediately we return res.json, which remember will return a new promise, and it is this one which then will get the data, because the data is going to be the resolved value of this promise. Right, so that's nothing new. And so let's just take a look at the data here. All right. So let's reload here. Oh, and of course, I need to call this function indeed. So let's grab these coordinates, give it a save. And so now it actually already worked. All right. So let's open it and let's see what kind of stuff we have here. So we have the city, we have so basically the confidence that this data is correct, which is 90%, which is pretty good. So the country is Germany, and then here we have all kinds of stuff. But what matters is actually the country, at least for part 2, which is going to be to render the country. But for now, the task is to log to the console a string, you are in city and then country. So like in Berlin, Germany. Okay, so let's do that. So you are in, and then data.city, data.country, country like this. And all right. So we are in Berlin, Germany. Let's actually already do this with the other coordinates. So let's see what countries we are in. I actually have no idea. All right. So we get undefined, undefined. And so this is actually the problem that I was mentioning right at the beginning. So, so this one, where the API, sorry. So where the API only allows 3 requests per second. And so now we got this error 4 or 3. And so indeed, it is exactly this one. All right. And so one more time, the fetch function is not correctly handling this error. So it is not rejecting the promise, even though this clearly is an error. And so, as you already know, we need to now manually do that. So here we need to now return. And just to make sure, let's take a look at the response. And this doesn't always happen. Okay, and so in this case, it actually worked just fine. So one of these here is Cape Town, South Africa. And the other one is Mumbai in India. All right. So let's try to reload again very fast here. And so now we get that error again. Okay. So where is that response? So the one that's associated to 13.381. So that's this one. And so one more time you get that okay is false. So let's use that to our advantage. So if res.ok is false, then throw new error with the error message problem with geocoding. And again, let's actually include the status code here. All right. So here we are throwing a new error. And so we are rejecting this promise that's going to be returned here. But we are, as of now, not catching it anywhere. And so at this point, we would have an unhandled promise rejection. And actually, let me show that to you. So I need to save this a bit faster in order to create the error. So sometimes it's not that easy to catch it. Let's do it really fast here. All right. So now you get uncaught promise, basically. So the error message is already the one that we want, but it should not be uncaught, right? And so indeed, we need to catch any promise rejection. And so let's do that. And all I'm going to do in this case is simply log it to the console as an error. Simply the error dot message. And then I will again like add an emoji here, just so we know that it's our own message. Okay, something is missing here apparently. So here again, we get problem with geocoding. And so now we successfully handled the error and could now do something more meaningful with it if we had to. Like, again, displaying some kind of error message or logging this error in some error tracking application. Now, okay. So I think with this, we actually already completed part 1. So we did 4 and 5 in the opposite order, but that's okay. And so now it's time to use this data to render a country. And so this is essentially what we already did before. So I'm just going to come here and copy that. So let's see where that is. Well, it's even more up there. Or actually, it's not. So actually, I will just copy this part here of the error handling. Oh, and actually, I can get all of it. Okay. So let's paste that here then. Let's get rid of these comments. And of course, now here, we need to do a new fetch. So return fetch. And then, well, actually, I need to go back and get the country as well. So yeah, that's essentially this URL here. Okay. So let's save it. I'm not sure if it's going to work yet. And it doesn't. And that's, of course, because this country here doesn't exist. So the country that we need is stored in data.country. And so here we are now logging this string just like we were doing before. And then based on that country, we have our next fetch here, which we will then return. And then here we have that part where we handle the error if the country cannot be found. And finally, here then we render that country. But it is not going to be a neighbor. So let's get rid of this part. And up there, we called response simply res. So let's do the same here. And for now, let's test it only with one testing data. So let's see. And now we still get an error, cannot read property 0 of undefined. So where does that come from? And so this stack trace here is once again not really helpful. But I think that I still know the answer. And that is because here we actually needed to take the first element of the array. If I remember correctly. Well, no, nothing happened. Oh, but I think I know why. And the reason for that is that previously we had this finally here. So we had this finally, which set the countries container opacity back to 1. And as we did that, we removed this from here. So right here. So basically, now we should set this back here so that we can be back to using it in the future. And so if I save this now, oh, beautiful. There you have it. And this is really amazing. So just using the GPS coordinates, we can now determine the country that we are in and then also display it along with a bunch of information about the country here on our page. And all thanks to the power of APIs and also asynchronous JavaScript. So let's now also test with these two. All right. But now here in one of them, we actually got an error with geocoding. And again, the reason for that is that we can only do 3 requests a second. And so sometimes this then doesn't really work. Oh, but now we actually got all 3. Now, this one here for India looks a bit weird. Right? So this one is India, but when we get the data for India, then apparently, because this country also has Indian in its name, this is then going to be the first country that is found. Right? So there's probably multiple countries for India. But yeah, that doesn't really matter here in this case. If you want, you can just use some other coordinates here. All right. But anyway, again, I hope you had some fun. And this was a great use case for how we can actually use multiple APIs in sequence to create a really amazing result like this one. So we learned what AJAX and APIs are. We used a bunch of asynchronous code already, and we learned all about promises. But what's missing is to finally understand how all of it really works behind the scenes of JavaScript. And so let's find out. And to start, let's quickly review the JavaScript runtime that we talked about way back in the course, just to make sure that the rest of this lecture will make sense to you. So a JavaScript runtime is basically a container which includes all the different pieces that are necessary to execute JavaScript code. Now, the heart of every JavaScript runtime is the engine. So this is where code is actually executed and where objects are stored in memory. So these two things happen in the call stack and in the heap. Now, what's important to note here is that JavaScript has only one thread of execution, and so it can only do one thing at a time. There is absolutely no multitasking happening in JavaScript itself. Now, other languages like Java can execute multiple pieces of code at the same time, but not JavaScript. But anyway, next we have the Web APIs environment. These are some APIs provided to the engine, but which are actually not part of the JavaScript language itself. So that's things like the DOM, timers, the fetch API, the geolocation API, and so on and so forth. Next up, there is the callback queue. And this is a data structure that holds all the ready-to-be-executed callback functions that are attached to some event that has occurred. Finally, whenever the call stack is empty, the event loop takes callbacks from the callback queue and puts them in the call stack so that they can be executed. So the event loop is the essential piece that makes asynchronous behavior possible in JavaScript. It's the reason why we can have a non-blocking concurrency model in JavaScript. And a concurrency model is simply how a language handles multiple things happening at the same time. But now, how does this non-blocking concurrency actually work? And why is the event loop so important? Well, let's find out. And let's focus on the essential parts of the runtime here. So that's the call stack, the event loop, the web APIs, and the callback queue. So as you know by now, a JavaScript engine is built around the idea of a single thread. But if there's only one thread of execution in the engine, then how can asynchronous code be executed in a non-blocking way? Well, that's actually the big question that we're going to answer in this video. So essentially, you will learn how the JavaScript concurrency model really works behind the scenes using all the parts of the JavaScript runtime that you already know. And as always, we will do this by looking at a real code example. So let's walk through the code line by line, and I will keep updating the call stack as we go. However, you already know how the call stack works, and so it's best that you focus more on the code and on the web APIs and callback queue. Okay, but now let's start by selecting this image element, and then in the next line, we set the source attribute of that image to doc.jpg. And as we learned before, this will now start to load this image asynchronously in the background. But this time we can actually understand what that mysterious background actually is. So, as you already know, everything related to the DOM is not really part of JavaScript, but of the web APIs. And so it's in the web APIs environment where the asynchronous tasks related to the DOM will run. And in fact, the same is true for timers, AJAX calls, and really all other asynchronous tasks. So again, these asynchronous tasks will all run in the web APIs environment of the browser. Now, if the image would be loading in a synchronous way, it would be doing so right in the call stack, blocking the execution of the rest of the code. But as we already learned, that would be terrible. And that's why loading images in JavaScript is asynchronous. So it does not happen in the call stack, so not in the main thread of execution, but really in the web APIs environment, as I mentioned before. Now, if we want to do something after the image has finished loading, then we need to listen to the load event. And so that's exactly what we do in the next line of code. So here we attach an event listener to the load event of that image and pass in a callback function as always. In practice, this means to register this callback in the web API's environment exactly where the image is loading. And the callback will stay there until the load event is emitted. So we're handling asynchronous behavior here with a callback, just as we learned before. But anyway, let's go back to the code. And so in the next line, we make an AJAX call using the fetch API. And as always, the asynchronous fetch operation will happen in the web API's environment. And again, that's because otherwise we would be blocking the call stack and create a huge lag in our application. Finally, we use the then method on the promise returned by the fetch function. And this will also register a callback in the web API's environment so that we can react to the future resolved value of the promise. So this callback is associated with the promise that is fetching the data from the API. And that's going to be important later on. So with this, we have now executed all the top level code, so all the code that is not inside any callback function in a synchronous way. We also have the image loading in the background and some data being fetched from an API. And so now it's time for this to get really interesting. Let's say the image has finished loading, and therefore the load event is emitted on that image. What happens next is that the callback for this event is put in the callback queue. And the callback queue is basically an ordered list of all the callback functions that are in line to be executed. And you can think of this callback queue like as a to-do list that you would write for yourself with all the tasks that you have to complete. So the callback queue is also a to-do list of a kind, but with tasks that the call stack will eventually have to complete. Now in this example, there are no other callbacks in the queue yet, but there could be, of course. So if there were already other callbacks waiting in line, then this new callback would of course go straight to the end of the queue, and there it would sit patiently for its turn to finally run. And this actually has big implications. So imagine that you set a timer for 5 seconds. And so after 5 seconds, that timer's callback will be put on the callback queue, right? And let's say there were already other callbacks waiting, and let's also say that it took 1 second to run all of those callbacks. Then, in that case, your timer's callback would only run after 6 seconds and not after 5. So these 6 seconds are the 5 seconds that passed for the timer, plus the 1 second that it took to run all the other callbacks that were already waiting in line in front of your timer. So what this means is that the timer's duration that you define is not a guarantee. The only guarantee is that the timer's callback will not run before 5 seconds, but it might very well run after 5 seconds have passed. So it all depends on the state of the callback queue and also another queue that we're going to learn about in a second. Now, another thing that's important to mention here is that the callback queue also contains callbacks coming from DOM events like clicks or key presses or whatever. Now, we learned before that DOM events are not really asynchronous behavior, but they still use the callback queue to run their attached callbacks. So if a click happens on a button with an event listener, then what will happen is just like what I illustrated here with the asynchronous load event. But anyway, now it's time to finally learn about the event loop. So here is what the event loop does. It looks into the call stack and determines whether it's empty or not, except of course for the global context. Then if the stack is indeed empty, which means that there is currently no code being executed, then it will take the first callback from the callback queue and put it on the call stack to be executed. And this is called an event loop tick. So each time the event loop takes a callback from the callback queue, we say that there was an event loop tick. So as we can see here, the event loop has the extremely important task of doing coordination between the call stack and the callbacks in the callback queue. So the event loop is basically who decides exactly when each callback is executed. We can also say that the event loop does the orchestration of this entire JavaScript runtime. Another thing that becomes clear from this whole explanation is that the JavaScript language itself has actually no sense of time. That's because everything that is asynchronous does not happen in the engine. It's the runtime who manages all the asynchronous behavior, and it's the event loop who decides which code will be executed next. But the engine itself simply executes whatever code it is given. Okay, so this is of course a lot to take in, so let's try to recap what happened here. So the image started loading asynchronously in the web API's environment and not in the call stack, right? We then used addEventListener to attach a callback function to the image load event. And this callback is basically our asynchronous code. It's code that we deferred into the future because we only want to execute it once the image has loaded. And in the meantime, the rest of the code kept running. Now, addEventListener did not put the callback directly in the callback queue. It simply registered the callback, which then kept waiting in the web API's environment until the load event was fired off. Only then the environment put the callback in the queue. Then, while in the queue, the callback kept waiting for the event loop to pick it up and put it on the call stack. And this happened as soon as the callback was first in line and the call stack was empty. And that's it, actually. So all this happened so that the image did not have to load in the call stack, but in the background in a non-blocking way. So in a nutshell, the Web API's environment, the callback queue, and the event loop all together make it possible that asynchronous code can be executed in a non-blocking way, even with only one thread of execution in the engine. Wow, that was already a lot to understand, but we're not done yet, because we still have the fetch function getting data from the AJAX call in the background. And this is basically happening with a promise. Remember? Now, with promises, things work in a slightly different way, which is why I included this promise example as well. So let's say that the data has now finally arrived, and so the fetch is done. Now, callbacks related to promises, like this one that we registered with the promises then method, do actually not go into the callback queue. So again, this callback that we still have here, which is coming from a promise, will not be moved into the callback queue. Instead, callbacks of promises have a special queue for themselves, which is the so-called microtasks queue. Now, what is special about the microtasks queue is that it basically has priority over the callback queue. So at the end of an event loop tick, so after a callback has been taken from the callback queue, the event loop will check if there are any callbacks in the microtasks queue. And if there are, it will run all of them before it will run any more callbacks from the regular callback queue. And by the way, we call these callbacks from promises microtasks, and therefore the name microtasks queue. And there are actually other microtasks, but that's not relevant here. So going back to our example, currently we actually do have a microtask sitting in a microtasks queue. The call stack is also empty, and therefore the event loop will now take this callback and put it in the call stack, just like it does with callbacks from the callback queue. And it doesn't matter if the callback queue is empty or not. So this would have worked the exact same way, even if there were some callbacks in the callback queue. And again, that's because microtasks always have priority. In practice, this means that microtasks can basically cut in line before all other regular callbacks. Now, if one microtask adds a new microtask, then that new microtask is also executed before any callbacks from the callback queue. And this means that the microtasks queue can essentially starve the callback queue, because if we keep adding more and more microtasks, then callbacks in the callback queue can never execute. Now, this is usually never a problem, but I just wanted to mention this possibility here anyways. Who knows? Maybe this will be an interview question for you someday. And if so, you would now know the answer. But anyway, as you can hopefully see, the idea of running asynchronous code with regular callbacks and with microtasks coming from promises is very similar. The only difference is that they go into different queues and that the event loop gives microtasks priority over regular callbacks. Alright, and that's finally it. That's all you need to know about how asynchronous JavaScript really works behind the scenes. And I'm sure that this knowledge is going to be extremely helpful and valuable to you, because you're going to be way more confident writing asynchronous code now, and also you will ace any job interview question about asynchronous JavaScript. And actually, so many JavaScript developers don't know anything about this. So I'm sure that this knowledge will put you into the top 10% or even top 5% of JavaScript developers. And that's just amazing on itself, right? But anyway, let's now finish here and try out some of this stuff in practice so that you see for yourself that I didn't just make this stuff up. Let me now quickly show you some of the stuff that we just learned in practice. And so let's now build an extremely simple example. So I will start by simply logging test start to the console. Then afterwards, I will create a set timeout with something that will just also log something to the console only. So 0-second timer. And so that's because we will fire this timer after exactly 0 seconds. Okay, so basically this is a timer which should call this timer function exactly after 0 seconds. So what that means is that after 0 seconds, this callback will be put on the callback queue, right? Then next up, let's build a promise that resolves immediately. So this is something that we will learn in the next video actually. And so for now, just follow what I'm writing here. So promise.resolve basically allows us to build a promise, so to create a promise that is immediately resolved. So one that immediately has a success value. And so that fulfilled success value is going to be this one we passed in here. So resolved promise 1. And then we can handle that resolved promise. And so that response, we can then simply log it to the console. So just like in any other promise, we can handle it with the then method. And this callback function here will get called with the resolved value as an argument. And so in this case, the resolved value of that promise is this one here that we just specified. And now just to finish, let's just log another string, test, end. And so for now, that's actually it. So in what order do you think that these 4 messages that we have here will be logged to the console? And I want you to really think about this and maybe even pause the video and write it down. Well, let's think about this together before we actually check out the result. So the first 2 messages that are going to be printed should be pretty obvious. That's because we already know that any top-level code, so code outside of any callback, will run first. And so, of course, the first 2 logs will come from these 2 synchronous console.logs here. But now between the timer and the resolved promise here, it might be a little bit trickier. So both the timer and the promise will finish at the exact same time. So both right after 0 seconds. So the timer, because we told it to finish after 0 seconds, and the promise, because we told it to immediately become resolved, right? And so therefore, they will both finish at the exact same time. So which one do you think will be handled first? Or in other words, which of these 2 callbacks here will be executed first? Well, the timer appears first in the code, and so it kind of finished first, and so its callback will be put on the callback queue first. But does that mean that this callback here will be executed first? Well, actually no, it doesn't. And that's because of the microtasks queue. Remember? So the callback of the resolved promise here, so this one, will be put on the microtasks queue. And this microtasks queue, as you learned in the last video, has priority over the callback queue. And so after this whole code runs, we will have 1 callback in the callback queue and 1 in the microtasks queue. And therefore, the one from the microtasks queue should be executed first. And so therefore, the callback from the microtasks queue should be executed first. And so that's this one here. And therefore, the first message to appear of these 2 should be resolved promise 1. All right. So the order in which they should appear is this, then this, then this, and finally the timer. And so let's now finally confirm this. So I'm saving it. And indeed, that is exactly as expected. And so that's a relief actually. So what I told you in the last lecture is actually true. Now we proved it with code. Now remember that the implication of the fact that microtasks have priority over regular callbacks is that if one of the microtasks takes a long time to run, then the timer will actually be delayed and not run after the 0 seconds that we specified here, right? So instead, it will run a little bit later, just after the microtask is actually done with its work. And so to finish this lecture, let's actually simulate what I just said. So here I will create another promise that will immediately resolve. So let's just say resolved promise 2. And then again, we can handle it here. And then as always, we want to log the result to the console. But before we're doing that, we actually want this callback function to have a really heavy task, which should take a lot of time. And so let's simulate that this callback takes a long time to run by looping over a large number. So we can do the simulation simply with an old school for loop. So let's start with I at 0. And now I will loop all the way until one very large number, let's say this. And I will have to experiment a little bit. And for your computer, it might indeed be different. So if your computer is slower, maybe then you want a smaller number. And maybe it's faster than mine, and then maybe a smaller number will be enough, right? I'm not sure if I said it correctly. So if your computer is slower than mine, then you will need a larger number, right? And so again, this line of code here will simulate that the callback function takes a long time. So really just this microtask takes a long time, all right? It is not the asynchronous task itself. So the promise itself will still be resolved immediately, but then the microtask that it contains, so that it puts on the microtasks queue, that's the one that will take a long time. And so by doing that, I can show you that the callbacks in the callback queue, just like this one here, will indeed be delayed and not run after 0 seconds. So let's try this now. And you see, it took a long time here until this log appeared, right? So maybe we can have even a bigger number. And I hope that my computer is not going to explode with this one. So you see that the page is kind of loading here and it's taking a lot of time. And so actually now eventually it finished, but you see that now only after all this work, the 0 second timer message appeared on the screen. And so this is actual proof that these 0 seconds that we have here are not a guarantee, okay? And that is exactly what I wanted to show you. So this means that you cannot really do high precision things using JavaScript timers. So just keep that in mind whenever you are working with promises. So basically with microtasks and with timers at the same time. Okay, let's just remove this 0 here so that you don't explode your computer, but you still see that the effect is the same. All right, and that's actually enough for this video. I think I proved my point and demonstrated the things that we just learned in the previous lecture. And so now we're ready to go back to some more practical aspects of asynchronous JavaScript. And that will be to create promises from scratch in the next video. So at this point of the section, you know all about consuming promises, but we have never actually built our own promise. And so let's do that in this lecture. And let's go back to our lottery example from the slides and basically simulate a lottery using a promise here. And remember that in that example, a fulfilled promise means to win the lottery, while a rejected promise means to lose. So let's get to work, and we create a new promise using the promise constructor. So that's new promise like this. So just like many other built-in objects. And so what this means is that promises are essentially just a special kind of object in JavaScript. Now, the promise constructor takes exactly one argument, and that is the so-called executor function. So we need to pass in a function here. And so again, this one is called executor. Now, as soon as the promise constructor runs, it will automatically execute this executor function that we pass in. And as it executes this function here, it will do so by passing in two other arguments. And those arguments are the resolve and the reject functions. So reject like this. So we will use them here in a second, but for now, let's actually build this executor function. And also, we should probably store the result, so this new promise, in some variable. So lottery promise. Okay, so all of this here will create a new promise that we're going to store into this variable. So it's just like, for example, the fetch function, which also creates a new promise. Now, this executor function that we specified here is the function which will contain the asynchronous behavior that we're trying to handle with the promise. So this executor function should eventually produce a result value. So the value that's basically going to be the future value of the promise. And so let's do exactly that right here in the executor function, and starting with a simplified version. Now, in our lottery example, let's say that we actually win in 50% of the cases and lose in the other 50%. So a very simplified example, just to make this a bit more fun. And so what I'm going to do is to simply generate a random number, which remember is going to be between 0 and 1. And so I can simply say, if this number here is greater or equal than 0.5, then I want to call the resolve function. And so now this is where this resolve function that was passed into the executor function comes into play. All right. So in this situation here, we say that we win the lottery. And so therefore, that means a fulfilled promise. And in order to set the promise as fulfilled, we use the resolve function. So basically calling the resolve function like this will mark this promise as a fulfilled promise, which we can also say a resolved promise. And that's the reason why this method here is called resolve. Now into the resolved function here, we pass the fulfilled value of the promise so that it can later be consumed with the then method, right? So of course, we are going to handle the result of this promise just like we handled any other promise with the then method. So again, whatever value we pass into the resolve function here is going to be the result of the promise that will be available in the then handler. And so in this case, let's simply pass in a string here, and let's use some emoji again to make it a bit more fun. And so now let's handle the opposite case. So where we basically want to mark this promise as rejected. And so as you can imagine, for that, we can call the reject function. Then into the reject function, we pass in the error message that we later want to be able in the catch handler. So in the catch method, right? So here, let's just say you lost your money and then just some poop emoji. All right, so give this a save here. So just to quickly recap before we consume this promise, here we created an executor function, which is going to be called by this promise constructor as soon as it runs. So basically immediately, right? Then the promise calls this function and passes in the resolve and the reject functions so that we can then use them to mark the promise as either resolved, so as fulfilled, or as rejected. And so you see that this promise is eventually going to move to either the fulfilled state or the rejected state. So we always need to make sure that the promise ends up in one of these two states. All right, and so now it's time to actually try this out by consuming this promise that we just built. So lottery promise is going to be a promise object at this point, and so then, as always, we can call the then method. And then, just like before, the then method needs a callback function that is going to be called with the resolved value of the promise. So let's call this res here. And then let's simply log it to the console. Okay, and of course, once again, this could be any name here, right? And now let's also catch any errors. And so here also, as always, we will simply log it to the console as an error. Now, okay, and so that's actually it already. So what do you think this res value here is going to be, or this error is going to be? Well, as I just explained before, the resolved value of the promise is going to be this one that we pass in here. And so therefore, the value that we're going to log in the case that the promise is successful is going to be exactly this string that we passed into the resolve function. And the same is true with the error. So the error here is going to be simply this one, because that's the string that we passed into the reject function. Okay, so let's see. And indeed, we get our error. So you lost your money. And so as we keep reloading, we should then see these different states according to this random number that was generated here. Great. So now we won. And so as we keep doing this, we can see the different states that the promise will take. So that's amazing. But however, right now, this is not really asynchronous yet, right? So let's actually simulate this lottery draw by adding a simple timer. And so this timer will then simulate the time that is passed between buying the lottery ticket and actually getting the result. So let's add a set timeout here. So with a simple callback function, and let's run it for 2 seconds. And here we will simply take this code and put it here. And then we can also immediately log something to the console, like lottery draw is happening. And then let's add like a crystal ball here. So that's exactly also what we had in the slides. All right. And now another thing that we can do is to, instead of passing just a string here, we can also create a new error object. So basically creating a real error. And so that's a little bit better. So just like this. And so with this, we made this whole promise here make a little bit more sense, because now by using this timer, we did actually encapsulate some asynchronous behavior into this promise. And so that's the whole point of promises in the first place, right? So let's give it a save to see what happens. So immediately we get this here, and then after 2 seconds, the promise was resolved. And so then here we handled that result and logged it to the console. Let's try again. And of course, again, this one comes immediately. And we win again. Let's see if we can lose. Apparently, we can only ever win. But here you go. So now we get the error message just like before. But we also now see that it's an error. And it also tells us where this error is coming from. So right at line 292. So that's right here. And so indeed, actually creating a new error object is actually a bit better. Great. So this is how we encapsulate any asynchronous behavior into a promise. So how we abstract it away in a very nice way, just like we did here, right? And then all we have to do is to consume that promise like this. And so this is a really nice and helpful pattern. Now in practice, most of the time, all we actually do is to consume promises. And we usually only build promises to basically wrap old callback-based functions into promises. And this is a process that we call promisifying. So basically, promisifying means to convert callback-based asynchronous behavior to promise-based. All right. So let's see that in action a little bit. And so what we're going to do is to actually promisify the setTimeout function and create a wait function. Okay. So let's create a function called wait. And this function is going to take in a number of seconds. Okay. And so now inside of this function, we will actually create and return the promise. So usually that's always what we do. So creating a function and then from there returning a promise. And so this will then encapsulate the asynchronous operation even further. So essentially that's also what the fetch function does, right? So it's a function that returns a promise. And so that is exactly what we will do here with this wait function. So in a sense, this here is a more real-world example. So promisifying setTimeout. So as I was saying, we are going to return a new promise. And then our executor function as always. And then resolve. And in this case, we actually don't even need the reject function. And that's because it's actually impossible for the timer to fail. And so therefore, we will never mark this promise as rejected. And so here we don't even need to specify that reject parameter. All right. So it's just like the array methods like map, which always receive 3 arguments, but most of the time we just use 1 or 2 of them, right? And so this is similar. But anyway, all we have to do now is to use setTimeout. And then here the callback function that we want to be called after a certain time is exactly the resolve function. So we can simply do this. And in this case, we're actually not even going to pass any resolved value into the resolve function because that's actually not mandatory. And so in the case of this timer, it's also not really necessary. And so in the case of a timer, it's also not really necessary to wait for some value, right? So in this case, all we want to do is to basically make our code wait. And so no resolved values are needed. Now here we want to run that timer for a certain amount of seconds. So we need to multiply that by 1,000. And so that's actually already it. Now we could improve this even further here, or just make it smaller by using arrow functions. And you can do that if you want to have some fun with that. But for now, I will simply now consume this promise. So let's call our wait function. All right. And so this will now create a promise that will wait for 2 seconds. And after these 2 seconds, it will resolve. And so we can then handle that. And then here in our callback function, remember, we are not going to receive any resolved value. So we just leave this empty. And then I will simply log, I waited for 2 seconds. And so here in this callback, we could now run any code that we wanted to be executed after 2 seconds, right? And then let's actually wait 1 more second. And so just like before, we now have to return a new promise here. So return, wait, and this time just 1 second. And so this is exactly what we did before when we wanted to chain two sequential AJAX calls using the fetch function, right? So in the result of the first fetch, we would create a new fetch and return it. And so that's what we're doing here. And so then therefore, all of this returns a new promise. And then we can one more time handle that. And let's just say again, I waited for 1 second. All right, so give it a save. So this one waited for 2 seconds and this one for 1 second. And of course, we also still get the result from the previous one. But for now, this is here what we are interested in. And so now with this, we have once again a nice chain of asynchronous behavior that happens nicely in a sequence, and all without the callback hell. So before, I actually showed you what happened when we had multiple timers. And so basically, we could do now this same thing like this. So let's just copy it here as a reference. And so this example here would be this. So 1 second passed. So let's just overwrite this one here. And then here we can simply duplicate this a couple of times. So 2 seconds passed, 3 seconds, and here 4 seconds passed. All right. And so that's going to be exactly the same result as we had here. Of course, here it's 4, but never mind, that doesn't really matter. What matters is that now we no longer have this ugly and difficult to understand callback hell, but instead we have this nice sequence of asynchronous behavior. Now finally, there is also actually a way to very easy create a fulfilled or a rejected promise immediately. And we had actually already done that in the previous lecture, but it's always good to know that we can do this. So let me show it to you again. So we can use promise.resolve. And so basically this is a static method on the promise constructor, right? And so here we can then pass in the resolved value. So just like we would pass the resolved value right here. Okay. So again, the difference is that this one here will resolve immediately. So here, it doesn't matter. So just ABC, and then we can handle that. And so again, the values here don't matter. And then we can also do the same with reject. Let's just duplicate this here actually. So reject, and here the then is not necessary because there will be no resolved value anyway. And so we can just catch it like this. And so these two here should now appear at the very beginning. Well, actually they don't. So let's see. Oh, actually here they are. So here is ABC and then ABC. Here let's just create a new error. All right. And so indeed, here we got a lot of redraws happening, which comes from the previous promise. So right from here. And so that's because this is basically the first microtask ever. And so therefore, this first microtask needs to be executed first. And then after these, we have ABC, and then the problem that we created here in the end. All right, so this is how we build our own promises and how we promisify a very simple callback-based asynchronous behavior function, such as set timeout. Let's now keep promisifying things And this time around, we're going to promisify the geolocation API. And this is going to be really cool because it will allow us to take the small app that we built in the last coding challenge to the next level. Now, we used the geolocation API before, and so let's start by reviewing how it works. So remember, we use navigator.geolocation.getCurrentPosition. And then this function here accepts two callbacks, where the first is for the success and the second one is for the error. So this first callback function actually gets access to the position object. So let's pass that in as an argument to this callback function. And then let's simply log that to the console. So this is our first callback. And now let's create the second callback with the error. So for example, in case that the user does not allow the page to get access to the current location. And so in that case, let's just log that error to the console, just as we did previously. And so now, just like before, in the map.t app, JavaScript asks us for permission here. And when we allow, then at some point when JavaScript actually figures out the location, then we get that data back. And so here it is. And so again, this is actually asynchronous behavior in exactly the way that we have been talking about. So the code is not blocked, which we can check here. So we have a console.log after the geolocation part here, and still this part here is logged first, and so this one happens first. And so that's because this function here basically offloaded its work to the background, so to the web API environment in the browser, and then immediately it moved on right here to the next line, right? So this is very clearly a callback-based API, right? So we have to pass in these different callbacks. And so this is another great opportunity to promisify a callback-based API to a promise-based API. So let's do that. And it's actually pretty simple. So let's create a function here, just like before with the wait function. So get position. And we don't need to pass anything into this one. And just like before, we are going to return a new promise, which we then can handle later on. So here we pass in the executor function, which gets access to the resolve function and the reject function, which remember we can use to mark the promise as either rejected or fulfilled. All right. So let's actually grab this code here and paste it here. And now all we need to change is basically what happens here in each of these callback functions. So remember that this one here is the success callback function. And so it receives the position. And so when we have success, we want to resolve the promise, right? So we want to mark it as fulfilled. And so therefore we call the resolve function and we pass in that position object, because that is actually the fulfilled value that we want to get from this promise in case that it is successful, right? So that's the whole reason of using this function in the first place. It is to get access to the current position, and that is in this object. And so therefore, that's what we're going to pass into resolve, right? So in the last lecture, we just passed a simple string into resolve because that would then be the resolved value of the promise. So basically the future value of the promise. But in this case, it is this more meaningful object which we actually need outside of the promise here when we handle it. But anyway, here we do the same, but with reject. And so this is going to work just fine. But we can actually make this even simpler, because if this function here automatically calls these callback functions here, and if it also automatically passes in the position, then we can simply do this. So let's copy it here and I will comment this part. So we can simply do this. Resolve and reject. And that's it. So this is exactly the same as this one here. So before we specified the callback manually like this, but all we did was to take the position and pass it then into resolve. But here, that now happens automatically. So now resolve itself is the callback function, which will get called with the position, right? And so that's exactly what we do here, okay? And the same, of course, here with reject. And so now, let's actually try this out. So, get position, and then we want to handle the result. So again, this is exactly the same thing that we did previously with the fetch function, right? Or also with the wait function that we created in the last lecture. So let's now log this position to the console. And for now, we don't need the catch block. And so let's see. So it probably is now getting the position in the background. And yeah, so now we got it back. So the promise was marked as successful by the resolve function. And so therefore, then here, this callback was called in the then handler. And so the position was passed in. And here, finally, we logged it to the console. So beautiful. This worked just fine. And so we just promisified the geolocation API to a promise-based API now. But now let's actually take it to the next level. So remember how in the last coding challenge, we built a function which received GPS coordinates as an input and then rendered the corresponding country. Well, now we actually got these coordinates via geolocation, and so we don't even have to pass in any coordinates into that function. So let me actually get that function from the coding challenge. So that's this one here. And so remember, here we passed in the latitude and longitude, and then based on that, we did reverse geocoding, which gave us the country that basically these coordinates belong to. And so then, based on that country, we could get all the data about the country and then display it here on our page. But now, since we have this getPosition function, we actually no longer need to even pass in these coordinates. And so now we're going to be able to build a function that will tell us where we are in the world simply based on the geolocation of our device. So how cool is that? So we no longer need this one. And now here, this time, we are going to start by getting the position. So get position. And then let's do something with the position. So we already know that the coordinates are here in this coords property. I just don't remember if they are an array or an object. So let's log that to the console here for starters. So console.log position.coords. All right. And so for now, we'll just leave it at that. And we will not yet connect it to this part here. Okay. So let's run this. But probably we're going to get an error when we run this. Oh, and actually we first need to set it up with the event handler. So remember, that's the button. And then add event listener. And of course, we could also immediately run the function, but I think that it's nice to call it only when we click that button. And here we actually can simply pass in that function now, so the where am I function, because we don't need to pass in any arguments. So if we click now, yeah, so here then we get an error that latitude is not defined. But what we were interested in anyway is here the latitude and the longitude of this coords object. And so let's now go ahead and destructure this object. So const latitude and longitude equals this. But now here we call them lat and lng, and so let's do this. So basically giving them new names. And next, all we need to do then is to chain the next promise. And so let's grab this code here and put it in here. And so just like before, we now simply create a new promise here, basically, and then return that. And so then we can handle it here in the next then handler. Okay? And so now we have an even longer chain, as you can see. This one here still comes from here. No need for that anymore. And so now let's see what happens. So latitude is not defined, but that's because I got this syntax here wrong. So in destructuring, the equal sign is actually to set a default value. So this is not what we want. We want to still destruct latitude, and then we want to say that we basically want to create a variable called lat. So based on that latitude variable. And here lng to fit this one and this one, right? So let's try again. And so this takes some time. So in the real world, we would have like some loading spinner, but it works, right? So we got now the country that I'm currently in, which is indeed Portugal. And all of that was simply done using geolocation. So again, we got the coordinates here. Then from those coordinates, we got the location, so the actual location with country. And so then from there, we got all the data about the country. And so now we have the ability of basically displaying the flag of a country simply based on geolocation on any device. Now just imagine that you would have to handle all of these asynchronous operations here using callback function. So that would like literally be hell. So therefore the name callback hell. But again, with this, we have a really nice flat chain of promises that's easy to handle and also easy to manage. All right. But anyway, with this, we saw that we can really promisify all kinds of asynchronous stuff in JavaScript. For example, we could also promisify the old XML HTTP request function that we used in the beginning to make AJAX calls. Or also, we could promisify the image loading example that we have seen a couple of times in our slides. And actually, that's exactly what we're going to do in the next coding challenge. Time for coding challenge number 2. And in this one, your goal is to basically recreate what I'm just going to show you here on the screen. So when I open the page, then there will be an image loading in the background, and as soon as that arrives, it is displayed. Then after 2 seconds, it disappears, and another image starts loading in the background. It is then also displayed, and again after 2 seconds, it disappeared. And that's actually it. All right? So that's what I say right here. And so this time, the tasks are actually not going to be really descriptive. And so in this one, you should now pretend that you're actually working on your own. So at least a little bit. And in fact, this challenge is difficult on purpose. Okay, so this is not an easy one, but I hope that with some time and with some effort, and also with reviewing everything that we learned so far in this section, you can at least complete parts of this challenge. But anyway, let's now still take a look at your tasks here. So I want you to create a function called createImage, which receives as an input a variable called imagePath. So this is basically the path to an image that I will show you in a minute. Now this function should return a promise which creates a new image. So really a new image in the DOM, and for that you can use document.createElement with the image tag. And so this is how we learn to do it in the advanced DOM section, right? So you create that image and you set the source attribute to the provided image path that you received here. And as you already know, this setting the source path is an asynchronous operation. And so basically, your task in this part 1 is to promisifying all of that. So when the image is done loading, you should append that image to the DOM element that has the images class, and then resolve the promise. And the fulfilled value of the promise should be the image element itself. Okay? And in case there is an error while the image is being loaded, and so that is the error event that you need to listen for, so in that case, reject the promise. And again, if this part is too tricky for you, then you can always just start watching the solution, at least for this part. All right. And so after the first part of promisifying, the image loading comes, of course, consuming that promise. So after the image has loaded, I want you to pause the execution for 2 seconds using the wait function that we created previously. Then, after these 2 seconds have passed, I want you to hide the current image by setting display to none. And then you should load a second image. Now, in order to hide the current image, my hint here is that you use the image element that was returned by the createImage promise. So remember that the resolved value of the promise should be the actual image element itself. And so you can use that element to hide it. You will just need a global variable for that. But I hope that once you reach this part, you will notice that for yourself. Anyway, after the second image has loaded, so this part here in the step number 4, so after this has happened, I want you to pause execution again for 2 seconds. And then after these 2 seconds have passed, hide again the current image. So just to make sure you understood what exactly is needed, this is here what should happen. So the image is loading, then it's displaying, then it's hiding, and loading again. And so now it's hidden one more time. Now the images for doing this are here in this image folder. And so the path to these images is going to be image, so img slash, and then img1.jpg and img2. Okay? And here, to actually see this effect, go to the network tab and set your speed to fast 3G, because otherwise the images are going to load too fast for you to actually see any effect. All right? So again, don't stress if this becomes overwhelming and too difficult. So I designed this one on purpose to be a real challenge for you. And so if you need to watch parts of the solution, then don't worry about that at all. Okay? As always, what matters is that you actually try. But anyway, good luck for this one, and take all the time you need, and then I see you back here. Okay, welcome back. So I hope that you did at least part of it. And so let's start with the solution here. So create image, which should take in an image path. And then whenever we are promisifying something, we always return a new promise. And also the promise is always done in the same way, at least in the beginning. So we have the resolve function and the reject function, which are received by our executor function. Okay, now we are told to create a new image using document.createElement. And so we want to create an element of the type image, and so that's img. And then all we need to do is to set the source property of that to the image path that is received. Okay, And so then on that image, we can wait for the load event. And so let's see what was the task here. So when the image is done loading, append it to the DOM element with the images class and resolve the promise with the image element itself. All right, so let's out here select the element with the images class. So img container, let's say, dot query selector images. Let's just take a look here in the HTML. And so that's this element here, right? Now, okay. And so again, we should now append the image to that element. And so that's img container dot append, just again, like we learned in the advanced DOM section. So if you skipped that one, then maybe you needed this part of the solution. All right. But anyway, now we also want to resolve the promise, because this load event, of course, means that loading the image was successful. And so this is where we will then resolve the promise. So mark it as successful. And remember, the resolved value should be the image. And now we should also listen to the error event. Remember? And so in this case, we will then reject the promise with a new error, as always. And let's say image not found, because that is probably the most likely error. So here it actually says that we should test the error handler by passing a wrong image path. And so the error message here that makes sense is this one. Okay. And so this should actually complete part 1. And I know that I'm doing it quite fast here, but that's because we actually did many of the things here already before, but simply in a different context. But we already know what resolve and reject do, and so this, I think, should be understandable, right? But anyway, let's now handle the fulfilled, so the successful promise. And so that's this part here. And so remember that here we received the image as the resolved value. And now actually we don't need to really do anything here. So because the image is already being appended to the DOM up here. And so for now at least, we can just log something to the console, like image1 loaded. And then a bit later, we will actually worry about waiting these 2 seconds. So let's go here to our part. And of course, I need to actually pass in the path to the image. So as I said, that's image, and then VS Code is nice enough to give us that path. And indeed, here is the image already. So as I said, I will just set it here to fast 3G now. And so now you see it's taking some time, but eventually it will arrive. And so as it arrived after that, then we logged to the console image1 loaded. And so again, that happened because the promise was actually resolved. Let's also right away add the catch handler. And so here we just want to log the error, and let's format this nicely. So let's just change the name here. And now we get our error. So image not found. All right. And so now here we could do something more realistic, like giving the user a real error message or something here on the screen. But in this case, that's simply not necessary. So let's go back here and tackle step number 3, which is to pause the execution for 2 seconds using this wait function we created earlier. So let's grab that here. So this one. And I'm going to put it right here at the beginning. All right. And so now in here, we will wait for 2 seconds. And so this is going to return a promise. So this part here. And so let's now return that so that we can chain the next then handler on that. And wait doesn't have any resolved value, remember. And so we don't specify any argument or any parameter in this function. And now remember, here what we want to do is to then hide this first image. So this one. However, this image is only defined in this function, but not in this one. And so that's why I said previously that we are going to need a global variable to do that. So let's do current image. And then here, all we do is to set current image to the image. And then we can hide it right here. So that's current image dot style dot display set to none. And so this should load the image, and then after 2 seconds, it will hide it. So let's wait for it. 1, 2, and there we go. Great. So we have that working as well. And now load a second image. And yeah, that's actually it. So then we just have to pause execution again after 2 seconds and then hide the current image again. And so this one is now going to be simply the same. So where are we going to load the next image? Well, it's going to be right here so that we can then chain the next then handler into our chain here. So we will return a new promise, which is the one that is returned by create image. And this time, so I'm missing the quotes. Okay. And then another then. And so here we are back to receiving an image. And now let's just do exactly the same. So we assign the current image to image so that in the next step we can then hide it. Then image2 loaded, and we wait 2 more seconds. And then in the next handler, we hide the current image again. And so let's see. So after the second image has loaded, pause execution for 2 seconds again. Check that we did. And then after 2 seconds have passed, hide the current image. So check again. So we did both. And so our code should be complete now. And so let's wait for it. 1, 2, and there it goes. So now the second one is loading in the background in 1, 2 seconds. And that's it. That's our very small mini application, which had the simple goal of showing you how we can promisify this logic here of setting the source attribute of an image basically asynchronously. So I hope that you managed to do this part here. So promisifying all that and also then understanding the logic that I wanted to implement here. And if you did something a little bit different, then that's of course not a problem at all. Okay? So I keep saying it, but that's just because it's really true. So what I want is you to try and to practice, and the results will follow. If not today, then some other day. So now that you're super comfortable with consuming promises and also building promises, let's turn our attention back to actually consuming promises. That's because since ES 2017, there is now an even better and easier way to consume promises, which is called async await. So let me show you how it works. So we start by creating a special kind of function, which is an async function. So in this lecture, we will basically recreate the where am I function that we have been building. Where am I? And so function But for now, we will pass in the country again to make it simple at the beginning. But as I was saying, we now need to make this a special kind of function, which is an async function. And we do this by simply adding async here in front of the function. And so this function is now an asynchronous function. So a function that will basically keep running in the background while performing the code that's inside of it. Then, when this function is done, it automatically returns a promise. But more on that in the next video. For now, what's important is that inside an async function, we can have one or more await statements. So await, and then here we need a promise. And so we can use the promise returned from the fetch function. And so let's now use our API again to search for a country, basically. So let's see where we have some information about that. And here we go. So this is the URL that we have been using. So make sure you grab it somewhere from your code. And so here, let's now pass in this country again. All right. So again, this here will return a promise. And so in an async function like this one, we can use the await keyword to basically await for the result of this promise. So basically, await will stop the code execution at this point of the function until the promise is fulfilled. And so until the data has been fetched in this case. But now, after that explanation, you might think, isn't stopping the code blocking the execution? Well, that's a really good question. But the answer is actually no in this case. Because stopping execution in an async function, which is what we have here, is actually not a problem. Because this function is running asynchronously in the background. And so therefore, it is not blocking the main thread of execution. So it's not blocking the call stack. And in fact, that's what's so special about async await. So it's the fact that it makes our code look like regular synchronous code, while behind the scenes, everything is in fact asynchronous. All right? But anyway, as soon as this promise here is resolved, then the value of this whole await expression that we have here is going to be the resolved value of the promise. And so we can simply store that into a variable. So let's call it res for response. And then here we can take a look at that response. And just to show you that this function here is actually asynchronous, let's log something to the console before we call it. So just first, because this should be printed first, right? And then, or actually we should call the function first. So where am I with Portugal? But even by doing this, this console.log first will be displayed first. Because again, this is an async function. And so once the function is called, it is then loaded off to the background. And so this fetch here will be running in the background without blocking our main thread. And so the code will move on to the next line, which is then this console.log first. All right. And so, indeed, we got the first printed first, and then here we got the response. But this time we got this response in this really nice and elegant way. So you see here that by using async await, our asynchronous code here really looks and feels like synchronous code. So we can simply await until the value of the promise is returned, basically, and then just assign that value to a variable. And that is something that was impossible before. So before we had to mess with callback functions, and that was true in callback hell, but also by consuming promises with the then method. But now with async await, that is just completely gone, right? So again, this looks now like normal synchronous code, where we simply assign values to a variable. And that makes it so much easier and more clean in my opinion. Now, before you start using async await all over the place, you need to first understand that async await is in fact simply syntactic sugar over the then method in promises. So of course, behind the scenes, we are still using promises. We are simply using a different way of consuming them here in this case. But what we have here, so this, is essentially exactly the same as doing it the old way, basically. So using then, and then res, and then console.log res, like we did here. So this is exactly the same. So let's put that here and comment it out, of course, because what we are interested in is indeed async await right now. So now that we know how async await works, it's time to actually recreate the whereami function. So first off, we need to get the JSON out of this response, right? And so remember, on the response, we need to call a JSON. And remember that this itself returns a new promise. And so previously, we would have to return this promise and then chain another then handler. But now this becomes so much easier. All we have to do is to again await this, and then we can store the result directly into the data variable that we have been using before. Right? And so here it is. So here is the same data as before, and so now all we need to do is to render it. So render country and data at position 0. And in case you skipped any of the previous videos and don't have this render country function for some reason, you can simply get it from the final files of this section from the GitHub repository. So from where you also got the starter files. Okay, and yeah, there is our data, so rendered to the page here. Great, and all without the chaining of promises like we had before. So this is really elegant, one more time, simply being able to essentially store the fulfilled promise value immediately into a variable without having to mess with callback functions. Okay, but now let's actually finish the function here with all the other functionality as well. So with geolocation and also reverse geocoding. So for that, we need to get our promise that we built before for geolocation. So this is the one here. So let's get it. And so again, async await is only about consuming promises. The way that we build them is not influenced in any way. All right. So this here is going to work the exact same way. And so let's do that here before. And so get position, remember, doesn't need any arguments. And so, as you know, all we have to do is to now await this and then store the result into a variable. And just like before, let's simply destructure this. And in fact, let me get the code from before, so we don't have to repeat everything. So that was this code. And we also need the reverse geocoding, right? So let's paste all of that here. So what we want here is to get the latitude and longitude from position.coords. So probably we should just call this here first the position, and then from position.coordinates we get the lat and longitude just like before. And then now the next one. So now we can use these latitude and longitude and one more time plug them into this reverse geocoding API. And so now again, it becomes a lot easier to basically chain promises because we don't have to return anything, we don't have to create new then methods, and we don't have to create new callback functions. So all we have to do is to await this and store the result into some variable. So res for response, but we already have that. So let's call it geo for geocoding. And so let's take a look at that. Or actually, not yet, because remember that this is going to be just a response, and so we need to get the JSON from there. And yet another promise, but this is now so easy and so beautiful to handle. So again, data geo. Let's give it a save just to format it a little bit. And I will add some comments here. So geolocation, then reverse geocoding, and then country data. So just to make sure that it worked, let's take a look at data geo. And yes, this is it, right? And so again, here at the country property, we got Portugal. And so now we can plug that into this URL. So that's going to be data geo.country. And so now we can eliminate the country from here. And we also don't need to pass it in anymore. And so let's reload. And we still get the same data about Portugal because that is simply where I am right now located. But in case you're somewhere else, then you will now get the data about your own country. So let's just take a minute and appreciate how beautiful this data flow here is. Let me just put this comment out here so we don't clutter our async function. Okay. And so we now have all of this in one nice async function that runs behind the scenes until everything here is finished. So we are awaiting here 1, 2, 3, 4, 5 promises in a very easy way in code that now actually looks and feels like normal synchronous code. So to me personally, this async await feature was really a huge addition to the JavaScript language. Now, again, just keep in mind that async await is just synthetic sugar over consuming promises. So it's a bit like classes in JavaScript, which also hide the true nature of how things work behind the scenes. But I think that's no problem, at least if you already know exactly how promises and asynchronous JavaScript actually do work behind the scenes. And we spent a lot of time in this section learning all that, and so I'm sure that you will be fine. Also, async await is actually used a lot together with the more traditional then method of consuming promises, as we will see in the next video. Now let me just show you something, which is when we reload too fast here, then we should get that same error as before from the reverse geocoding, where we can only do 3 requests per second or something like that. Well, I guess I'm not fast enough here. Okay, but here we go. So here we have that 403 error. And so with this error, our whole example here falls apart. So we get this cascade of errors here and nothing works anymore. And the reason for all of these errors here is because right now we actually don't have any error handling here. And so let's fix that in the next video. In this lecture, we're gonna learn how error handling works with async await. So with async await, we can't use the catch method that we used before because we can't really attach it anywhere, right? So instead, we use something called a try-catch statement. And the try-catch statement is actually used in regular JavaScript as well. So it's been in the language probably since the beginning. So try-catch has nothing to do with async await, but we can still use it to catch errors in async functions. But before we do that, let's look at a more simple example just to see how try-catch works. So we can basically wrap all our code in a try block. And so JavaScript will then basically try to execute this code. So just as normal code. So let's just create a variable here, set it to 1, create another one. So this one is a constant. And now my goal was to reassign y, but I will accidentally, let's say, reassign x. And so that should then give us an error, because of course that is not legal. So we can't reassign a constant. And so for now, if we reload at this point, first we get this error that we are missing the catch block. So let's actually first do this here without any block. And so here, of course, we get the error assignment to constant variable, right? But let's go back. And so now here we can add the catch block. So we have a catch block, and this catch block will have access to whatever error occurred here in the try block. And so now we can do something with this error. So let's say we simply want to alert the error, or just the error message. So as we know, any error has the message property, and so we can simply alert that one. So let's see. And indeed, now we get assignment to constant variable here in this alert, and you see that the error now no longer appears down here in the console. So the script does no longer die in this case, and instead we can simply catch the error right here and then handle it accordingly. Okay? And of course, if there is no error at all, so if I was assigning y correctly, then we would get no error. Well, at least not coming from the try catch block. So now we're good. But anyway, this here is just a stupid syntax error. And of course, we're not going to use try catch to find mistakes that we make in our code. And so let's now use try catch for something more useful, which is to actually handle real errors in async functions. Okay, so just like in the small example that we saw, let's wrap our entire code of this function into a try block. All right, so curly braces and then try, like this. All right, and then down here, after that, the catch block, which remember has access to whatever error occurs in the try block. And so here in this catch block, we can now handle any errors just like we did before in the catch method. So let's log the error to the console, give it a save here just to format it a little bit better. All right. And so you see that the code still works the same, but that's because we didn't cause any error yet. But let's also now log the error message, but let's now also render the error. And so instead of going search that, I will simply write some new error message. So something went wrong. Then we had this emoji here, and then again the error dot message. Okay, and so now let's try again to force an error here by reloading really fast. Maybe the easiest way is to simply call this function multiple times. And now you see we get some nice errors here. Well, they're not really so nice. So let's see where they actually start. Well, for some reason, everything looks the same as before. But that's, of course, here it's render error. And here let's actually also add an emoji, just so we can see that it's our own error. So basically, that we are logging the error ourselves. Okay. So let's do this. Here we go. Whoa. So we get a lot of different errors here. So that's a couple of times. And so the reason for that is that we are calling this function here multiple times, and therefore we get multiple errors. But the error that gets logged here to the console, remember, is the one that is coming because of this 404 error that the country cannot be found. Okay? So at this point, we do have some error handling, so we are able to add the error here to the user interface. But just like before, this error is not really meaningful because the fetch promise does not reject on a 404 error or on a 403 error, which was actually the original error which caused everything here to collapse, right? So again, the 403 is because we are doing too many requests to the reverse geocoding API. But the solution is simple because it's exactly the same as before. So all we have to do is to manually create an error, and so that error will then be caught here in the catch block, right? So let's do that. So right here, so basically immediately after this fetch, and so just like before, we can test for the OK property. Remember, so I'm not going to show that again here because we already saw it before. So this response here will have the OK property, and if that is not set to true, well, then we want to throw a new error. So that's problem getting, let's say, location data. Okay. And so this one basically handles any error in this fetch. And so now the same here. So let's say that we come back with a real weird country from this fetch. And so then the second API cannot find any country for that name. And so here, let's just say problem getting country. Now, for this first promise here, this one, we do not need to throw an error manually. Because in the case that something goes wrong with the geolocation, we already built our promise so that it automatically rejects in that case. And so in this case, we will then immediately get an error, which will get caught in the catch block. But as we already know, the same is not true for the promise coming from fetch. So that promise only gets rejected when the user has no internet connection. But in case of a 403 error or a 404 error, the fetch promise does not reject. And so, again, we do that manually right here and also right here. And so here we already see that it worked. So here indeed we got something went wrong, problem getting a location, and then again here the same error. So here maybe we don't want all of this error message. Let's just take this one out so that we just have the emoji and then the error message itself. So the one that we defined here and here. All right. So let's see if this triggers an error. And yeah, for one of them, we now have problem getting location data. So an error triggered by this one. All right. So that is the complete version now of this async function, complete with a pretty robust error handling strategy. So again, please never ignore handling errors, especially when it comes to asynchronous code like this one. Because here, there's always a lot of stuff that can go wrong, and so our application needs to be ready to handle that. All right, but with that being said, in the next lecture, we're going to dive even deeper into how async functions really work. And so let's go there right away. At this point, we have a pretty good idea of how to work with async await, right? However, there is one important thing missing. So right now, it might still be a little bit unclear what an async function actually is and how it works. And so let's now fix that. So to understand a bit better what's actually happening here, let's start by adding some more console.logs here. So let's say we'll get location, and then in the second one here, we will say finished getting location. And if we check the result here now, I hope that you already know what the order of the logs here will be. So let's see. And so indeed, immediately we get the first log, then the second one, and of course, only after that, we get all the logs coming from the async function. So again, that's because this is an async function that runs in the background. And so JavaScript immediately moves on to the next line here. Now, if this was indeed a regular function, and there would be a console.log in that regular function, then of course that would appear here between 1 and 2, right? Well, let's call this 3 here actually. So it would then appear between 1 and 3. But in this case, it's an async function, and so therefore it runs in the background until the results are there. All right, but now let's say that we wanted to return some data from this function. All right. So let's first get rid of all these console.logs here. Put this all a bit better together. And so here at the end, let's now say we wanted to return a string like we had previously based on the geocoding data. So that data is in data geo. And so let's say you are in datageo.city, and then just quickly the country here as well. So we return this string here, and so let's say we now want to get, of course, that data out here. And so for now, let's pretend that this is simply a regular function, and then we would do this, right? We would simply define a variable, then there we would store that returned value, and then here we could take a look at that. But what do you think is going to happen here in this case? Well, let's see. And so the second thing that is logged to the console here is this promise. And remember that back then, when we first started to work with async await, I told you that an async function always returns a promise. And so here is the proof for that. And if we think about this, then it actually makes sense that here we get a promise and not the value that we would like to get. So this string here, right? So the reason for that is that at this point of the code, JavaScript has simply no way of knowing yet this string here that we want, because the function is still running, but it is also not blocking the code out here. And so therefore, again, at this point, JavaScript has no way of knowing what will be returned from this function. And so therefore, all that this function does return is a promise. Now, the value that we return from an async function, so again, that's this string here, will become the fulfilled value of the promise that is returned by the function. And so that's important to understand. So again, this promise that we see down here, the fulfilled value of that promise is going to be this string here, because that is the value that we return from the async function. Well, at least if there is no error here happening in the function. But for now, let's assume the success here again. So, since we know that this here will return a promise, we also know how we can actually get the data that we want. So all we need to do instead of this here is simply where am I? So let's comment out these two. And so this will be our promise. And so then, just like before, we can use the then method to get the fulfilled value of the promise. And so let's call that one city now. All right. So we're using the exact same variable name like we did here. But of course, this one here didn't work. But here it is going to work. Because again, in the then handler, this argument that will be passed into the callback function is going to be the resolved value of the promise. And so one more time, that is this string here that is returned from the async function. And so now let's see what happens. So let's wait for it. And so now we get our result. You are in Olhão, Portugal. Okay. And so with this, we essentially successfully returned a value from the function. Now we will be able to do a little bit better, but for now, let's think about errors. So if any error occurs here in this try block, then this return here will never be reached because the code will immediately jump here to the catch block, right? So let's just try to create some error here. So I will just change this one here. And so now nothing will work. So let's wait for it. And so indeed, now we have an error. And so now here we get undefined from line 543. And so that's this one. And so indeed, now nothing was returned from the function. And so we get undefined. Now, what's interesting here is that the log still worked. So this console.log here, which is now logging undefined here, is still running, which means that this callback function is still running, which means that the then method was called, which in turn means that this promise here was actually fulfilled and not rejected. So even though there was an error in the async function, the promise that the async function returns is still fulfilled and not rejected, right? And in fact, if we add a catch handler here, then let's see what happens. So console.error, so error.message, then our emoji here, and actually let's add a 2 here. So the sequence is kind of 1, 2, 3. And let's do the same here. All right. And so we should still get the error from here. And indeed we do. But still, it is this callback here that is executed. So that's why we get 2 undefined and not the catch block. And so again, what that means is that even though there was an error in the async function, the promise that it returns is still fulfilled. Now, if we wanted to fix that, so if we want to be able to catch that error here as well, then we would have to rethrow that error right here. So rethrowing the error means to basically throw the error again so that we can then propagate it down. And so with that, we will manually reject the promise that's returned from the async function. So let's say reject promise returned from async function. So here we can now take the error and throw it again. So throw error. And so now we get the same error here as we had here. So again, it's cannot read property flag of undefined, and here the same, and with this too. So it is coming from here. And so sometimes it's important to do this, and so rethrowing an error is then the correct solution to that problem. All right. And now, finally, if we wanted to fix not the error, but the fact that the 3 is printed before the 2, well, then how would we do that? Well, we can simply add a finally here, right? Because the finally, as you already know, is always going to be executed. So no matter what. All right. And so now we only get the 1, then we should get the 2 with the error, and then the number 3. And indeed, if we remove now the error from here, then 1, 2, 3, just as expected. All right. So I admit that this might have been a little bit confusing, but I hope that you understood how all the pieces fit together here. Now, this of course works just fine, but in my opinion, there's still a problem here. And that problem is the fact that doing this here kind of mixes the philosophy of async await with handling promises using then and catch, right? So we are mixing the old and the new way of working with promises here all in the same code. And that's something that I personally don't like. So I prefer to always just use async functions instead of having to mix them. And so let's now go ahead and convert this to async await as well. And we can do that because, of course, we can treat the promise here that is returned just like any other promise. And so, of course, we are able to handle it using async await. So that's what we're going to do next. Now, it would be great if we could simply use await without the async function, but that doesn't really work. At least for now, because there is actually a proposal in the works to make this happen, but for now, await can only be used inside an async function. However, we don't really want a new complete function here. And so instead, we can use an ify. So remember ifys from way back. They are immediately invoked function expressions. And remember that this is how we create one. So we write function, then here the function body, and then in the end, we simply call it. And so, of course, we can also easily create an async ify as well. All right. And actually, this pattern here is one of the last remaining cases for ifys. All right. And now I actually want to leave the conversion of this to the async function for you as a small challenge. So please pause the video now and take a minute or two and write the code yourself here. All right. So let's start with the try catch block. So try catch. Here we get access to the error. And then let's actually immediately do this part. And then here we can simply await the where am I promise. Okay. And then all we have to do is to store that result into the city variable and then log that to the console. So that's just this. And now finally, this last part here, we can simply put it outside of the try catch block. And so then it is always going to be executed no matter what. Okay. So let's comment this one out. And we should get the exact same result. And let's wait for it. And here we go. So great. We managed to do the conversion. And now everything is using async await. And so that's much nicer. And now we know how to basically return data from an async function and how to properly receive and handle that returned data, right? And actually in the real life, this is something that happens all the time. So it's pretty common that we have async functions calling other async functions and returning values between them. And so that's the reason why I'm showing you all this. So to make sure that you really correctly understand how async functions work behind the scenes. Let's now imagine that we wanted to get some data about 3 countries at the same time, but in which the order that the data arrives does not matter at all. So let's now implement an async function using everything that we know at this point. And this function will simply take in 3 countries, and it will log the capital cities of these 3 countries as an array. So let's say get 3 countries. And again, it's an async function. So country 1, 2, and 3. And then in an async function, we really always need to wrap our code into a try catch block. Okay, so never work an async function without this. And again, in a real world scenario, you would do real error handling and not just log it to the console. Okay, so await, and then let's use our getJSON function that we coded at some point at the beginning of this section. So here at the top of my file, I have this getJSON function, which, remember, encapsulates the fetch request, the error handling also. So basically, when there is an error in this fetch, it will throw a new error, and it also immediately converts the response to JSON. So again, if you skipped one of the previous lectures, then make sure to get this function from the final code of this section. So get JSON, and then here again we're using our REST countries API. So let me get the URL. So here we now will use C1. And so then we store that data into a variable just like this. So this is the magic of async await, right? Now we already know that the result of this is going to be an array with one object. So let's use the structuring to take the first element there. And now let's simply duplicate this code here twice and do this 3 times. So creating 3 variables for these 3 countries. And then what we want to get is the capital. So now let's say data1 dot capital, because there is such a property in each of these objects. And so remember that we want to return an array here. And so that's what we're doing. And data3 dot capital as well. And so this should actually already work. All right, so let's call this function get 3 countries. Let's use Portugal again, and Canada, and maybe Tanzania, which is a very beautiful country. Oh, and here we get something went wrong. So Portugal. So missing the G. And yeah, so here we get the 3 capital cities of the 3 countries. So great, this works just fine. And also at a first sight, this seems to make sense. But if we think about what we did here, then maybe it actually doesn't make so much sense. Because what we did here basically was to run all these AJAX calls one after another, even though the result of the second one here does not depend on the first one. And the result of the third one does also not depend on any of the other ones. And so actually this doesn't make much sense. Why should the second AJAX call wait for the first one? And actually let's take a look at this in our network tab here as well. So let's again maybe set this to slow 3G now. And then I will have to make it a little bit smaller so that we can actually see something down here. Okay, so down here, we actually have the 3 AJAX calls. So let's use fast 3G here actually. And so let's see what happens. And so basically these bars that you see here is JavaScript downloading something. So here, of course, the first one is the HTML, CSS, and JavaScript. So nothing strange there. But then here we load the data for Portugal. Right? So that's the first AJAX call. And then after that is finished, we load the data for Canada. And then after that is finished, we load the data for Tanzania. So just as we have it here in the code, And so, as I explained, that doesn't make a lot of sense. So instead of running these promises in sequence, we can actually run them in parallel, so all at the same time. And so then we can save valuable loading time, making these three here basically load at the same time. And each of them takes half a second. And so with that, we will basically save 1 second, which is actually a lot of time when loading a website. So let's do that. And for doing that, we use the promise.all combinator function. So promise.all. And so this is once again kind of a helper function on this promise constructor. So it's a static method, right? Now this function here takes in an array of promises and it will return a new promise, which will then run all the promises in the array at the same time. So let's simply grab these 3 promises from here. So 1, then here the second one, and this is the third one. Okay, so here we again have these 3 running. But you immediately saw the Portugal, Canada, and Tanzania already running another time, but at the same time, right? So I only wanted to show you this later, but now here it is already. But for now, let's keep focusing on making this work. So as I said, this here will return a new promise. So a promise that runs all of these promises at the same time. And so then we can handle that promise in the exact same way as before. So let's call the result data and then await it here. And then log the data to the console. So this one we also don't need anymore. So we want to log the data. And so, yeah, you see once again that these 3 now loaded exactly at the same time. So they are running in parallel and no longer in sequence now. So that's all I wanted to show you. So let's go back here. Okay, and so indeed here we get the result. So an array, which in this case returns 3 arrays, and each of them is of course the object we're looking for. And so promise.all receives an array and it also returns an array. And so to create the same output as before, now all we have to do is to loop over this data and take out the data that we want. So console.log, then data.map, because remember that we want to actually return an array, but not this array, but simply an array with all the capital cities. So in this array of data, each element, let's call it D, which stands for data. So D is now this single array. So from D, we want to take element 0, and then on there, we want the capital city. And so this should be it. And yeah, here we get the exact same result as before. Now, just one thing that's also very important to mention here is that if one of the promises rejects, then the whole promise.all actually rejects as well. So we say that promise.all short circuits when one promise rejects. So again, because one rejected promise is enough for the entire thing to reject as well. Great. So whenever you have a situation in which you need to do multiple asynchronous operations at the same time, and operations that don't depend on one another, then you should always run them in parallel, just like we did here using promise.all. And this is actually more common than you might think, and so please keep this technique in mind, because your users will thank you. And of course, just in case you're not using async await, you can of course also take this result here and then handle it with the then method. So that's going to work just exactly the same as here with async await. Okay, and that's the promise.all combinator. So it's called a combinator function because it allows us to combine multiple promises. And there are actually other combinator functions, and so let's take a look at them right in the next video. Let's now quickly talk about the three other promise combinators, which are raise, all settled, and any. And the first one we're going to talk about is promise.raise. So like this. And promise.raise, just like all other combinators, receives an array of promises, and it also returns a promise. Now this promise returned by promise.raise is settled as soon as one of the input promises settles. And remember that settled simply means that a value is available, but it doesn't matter if the promise got rejected or fulfilled. And so in promise.raise, basically the first settled promise wins the race. But let's now actually see this in action. And I will create a quick iffy here so that I can use async await without like creating a whole new function with a name. And so, as always, then we use await, promise, and in this case, .raise. And let's also store it here as a response. And now here let's define an array of promises. And let's just get this JSON here. So this get JSON function and try it with 3 countries. Let's say Italy and do this 3 times. Let's say Egypt and then also Mexico. And so now these 3 promises will basically race against each other like in a real race. Now, if the winning promise is then a fulfilled promise, then the fulfillment value of this whole race promise is going to be the fulfillment value of the winning promise. So that's more obvious than it maybe sounds. So let's just see the result here in the console. And so we got Italy. But if we try this again, then maybe we get another result, because then maybe another call is going to be faster. But well, it seems to be always Italy. But now it's Mexico. And let's actually see this in the network tab. So making it smaller again. And so you see that indeed Mexico is the one who took the least time. So it has the smallest bar here, and it also was the fastest of the 3. Right? This time the fastest was Egypt here by far, and so that's what we should see in the console. Okay? So again, just keep in mind that here in promise.raise, we only get one result and not an array of the results of all the 3. Now a promise that gets rejected can actually also win the race. And so we say that promise.raise short circuits whenever one of the promises gets settled. And so again, that means no matter if fulfilled or rejected. So let's try some weird name here. And so now it is the rejected promise that won, basically. But let's go back here to as it was and see another example, because in the real world, promise.raise is actually very useful to prevent against never-ending promises or also very long-running promises. For example, if your user has a very bad internet connection, then a fetch request in your application might take way too long to actually be useful. And so we can create a special timeout promise which automatically rejects after a certain time has passed. So let's do that. And it's going to be similar to the wait function that we created earlier, but the difference is that this one is actually going to reject and not going to resolve. So this time let's actually pass in milliseconds. Or, well, let's just pass in seconds, just to make it consistent with the other one. So return new promise. and the executor function. And again, in this case, we will not resolve, but reject. And so here for the resolve function, which is always the first one, we can once again use this throwaway variable. So using this convention. And then here reject and set timeout. And here we specify a callback function. And so we say that after a certain amount of seconds, let's call it sec, like this actually. So after this time has passed, we reject the promise. So we create a new error saying request took too long. And so now we can simply have the AJAX call that we were talking about earlier race against this timeout. All right. So let me show you what that means. So promise.raise. And then here, the first promise, let's use again or get JSON. So this is basically what we are interested in here. And let's use another country, Tanzania again. And the second promise is then going to be or timeout. So let's say that we only want to wait like 1 second. And so we will have these two then race against each other. And if the timeout happens first, then all of this here will be rejected, right? And so basically that will then abort the fetch that is happening here in getJSON. So I could have used, again, async await, but why not use the then method also here? So in this case, let's just log the response, or we could have called it data, but that's not really important here. And here the error. And let's just also log it to the console in case there is any. And so now we have request took too long, but that was very fast. Oh, and here we have to multiply it by 1,000. So again, this one takes milliseconds and not just seconds. Okay, so we got Tanzania pretty fast, and so it was faster than 1 second. And so therefore, it did not time out. But let's not try 0.1 seconds. And so now we see that the request took too long. So 0.1 seconds was not enough for this request here to get finished. And you will have to experiment with different values here because this is going to depend on your internet connection. So let's see 0.2 seconds. And so now the request was actually fast enough so that it didn't time out. So with 0.15 seconds, again, it takes too long. And so then this promise here is the result of promise.raise. So that's pretty useful. And in the real world, of course, you will use a larger number, let's say like 5 seconds. Okay, so that's promise.raise. And in fact, promise.raise and promise.all are by far the two most important promise combinators. But let me show you also the other two that we have. So the next one is promise.all settled. And this one is a pretty new one. It is from ES 2020. And it is actually a very simple one. So it takes in an array of promises again, and it will simply return an array of all the settled promises. And so again, no matter if the promises got rejected or not. So it's similar to promise.all in regard that it also returns an array of all the results, but the difference is that promise.all will short circuit as soon as one promise rejects, but promise.all settled simply never short circuits. So it will simply return all the results of all the promises. So promise.all settled. And so now here I will create actually the most basic example ever. So I will simply fake promises by saying promise.resolve success. All right. And so you already know that this here automatically creates a promise that is resolved. And so we don't have to wait for anything to finish like this here. Okay. So then we can have a couple of more. Here we have a rejected one. So let's say error, and here another one. Let's say another success. Okay. And then here we can just call then, and let's see. All right, now here we want actually all of the results. All right, and so indeed, here we get 3 results, even though one of them rejected. Okay, so this is the result of the 3 promises. And yeah, so this is how they look like when we do them manually with resolve, reject, and resolve. Just contrast that with promise.all. So that would then look different. So here we would get an error. Okay, so of course we can also catch the error then. And so here we would simply get error, and that's again because the .all promise combinator will short circuit if there is one error, if there is one rejected promise. So that's the difference between these two. But now let's go to the last one, which is promise.any. So like this. Now promise.any is even more modern. It is ES 2021. And actually at the time of recording, this one doesn't work in my browser, but probably by the time I'm releasing this course, it will work in the latest version of Google Chrome. And so let me simply do this here as well. So all I'm going to do is to just copy this example here and then do any. And this is not going to work. Let me show you. So we get promise.any is not a function, but again, in your case, it might already work. So let me simply explain what it does. So as always, promise.any takes in an array of multiple promises, and this one will then return the first fulfilled promise. And it will simply ignore rejected promises. So basically, promise.any is very similar to promise.raise, with the difference that rejected promises are ignored. And so therefore, the result of promise.any is always going to be a fulfilled promise, unless of course all of them reject. Okay, but at the time you're watching this video, again, this should already work, and then maybe you can experiment a little bit with this to see the difference between all the 4 promise combinators. And again, the most important ones are definitely promise.all and promise.raise. So keep at least these 2 in mind for your own projects. Welcome back to the last lecture of this section. And so in this one, we're going to apply everything that we learned in the last few videos to coding challenge number 3. And this coding challenge basically has 2 parts. So in the first part, I want you to write an async function called load and pause, which will basically recreate coding challenge number 2, but this time using async await. And so of course, that is only about the part where we actually consume the promise. Then you can compare the 2 versions that you have and think about the big differences and also see which one you like more. Now, in order to do this, don't forget to set your network tab to fast 3G. All right. So that's part number 1, basically converting what we did before. But then comes part number 2, which is again a more difficult one. And actually in this one, you will do something that we didn't do before, but I'm sure that with the instructions here, you can make it. So what I want you to do is to create an async function load all, and this one receives an array of image path. And so that's this one. So it's an array which contains the path of all 3 images in the image folder. Okay. So you receive that array in the function, and then I want you to use the map method to loop over the array in order to load all the images that are here in this array with the createImage function. So this one here, where we promisified loading an image. Okay. Of course, the map method will then result in a new array, and you should call this one images like this. Now keep in mind that createImage here will return a promise. And so the callback function of the map method needs to be special. So you need to consume the promise that comes from createImage. And so therefore, as I said, the callback function in the map method should be a special type of function. So I'm not spoiling which function it is, but hopefully you can guess what I'm talking about. All right. But anyway, next, I want you to check out this images array in the console. And is it what you expected? So again, here I want you to think about the result that you get. So this images array, and think if you expected it to be like this, and also if it makes sense. Okay, and what I just said will make sense once you get there. Then, in the next step, you should use a promise combinator function to actually get the images from the array. So this is a very important hint right there. Then finally, you should also add the parallel class to all the images. And so once again, you should probably loop over the images and then to each of them add this class. So again, this part 2 here actually contains some new parts that you will have to figure out on your own and experiment a little bit with that. But at this point of the course, so already pretty deep into it, it's probably a good idea that you start experimenting with some stuff on your own. And so that's why I created this challenge like this. So good luck with this, take all the time that you need, and then I see you back here. Welcome back here to my solution now. So as you see, I already have all the code here from challenge 2. And so what we're going to change now is basically this part here. So we will recreate this big then chain using now async await. So the function is called load, so load and pause, and it is an async function which doesn't have any arguments. I'm missing the function keyword. So it doesn't have any arguments. And so as always, we need to wrap everything into a try block. And then here the error. And actually right now it is already allowed to use catch without the error. So that's new in JavaScript. Previously that wasn't allowed. But just to make it consistent, I always use the error here, even if I then don't need it. But here let's just log it to the console as always. All right. So here is the first promise. So this one. So let's put that here. And since we're using async await, I will now await that promise and store the result into image. So that's basically the variable that we have here as the parameter in the then method. And so that's the same name that makes sense here. So image, and let's use 1 here because we're going to have multiple. Or actually that's not even necessary because this time we won't need the current image variable. Okay, but more about that once we reach that point. So again, the image is of course the result of this successful promise. All right, and so with that, we already translated this here. Now what we need is to simply log this to the console. And so here we have load image 1 already. Then next up, we have this wait. And so here we can just await for wait 2. And just like before, since the wait promise does not have any resolved value, we actually don't need to save anything to any variable. So here we basically just pause the execution for 2 seconds, and then what we want to do is this. But not exactly this, because now instead of current image, we can use simply image. And that's because now we are still here in the same function, or actually in the same block, and so in the same scope. While here, we defined the image in one function, and then we set the style in another function. And so then we needed to use this global variable. So like this, it is a lot better, of course. And so now we just need to do the same for image 2. So again, we don't need the external variable. We can now simply reassign image. So image 2, then image 2 loaded, and the rest works simply exactly the same. Here, let's just change to error, and with that, we should already be good to go. So load and pause, and here let me comment this out so that the same logic doesn't happen twice. And so this is already part 1. Let's set our network here to slow, or actually fast 3G. And let's actually inspect the images arriving here. So I think that this part here is really helpful. So seeing everything arrive, it's just a bit difficult. But anyway, let's just try it. And so here you see the image loading. And so then here was the waiting time of 2 seconds, and then the next image loaded and finished. So again, image 1 loaded during all this time. Then we had our 2-second waiting time right here. And then during this time, the second image loaded. And here we can actually get all this detail about that. So this is really interesting stuff if you want to dig deep into this. All right, but anyway, that's part 1. And so now let's go to part 2 to create this async function called load all, which receives image array. And then we loop over the array and create an array images. So just keeping these names in mind. So part 2 will be load all is an async function which takes in img r. Then as always, this block, so try catch. And now here we have to create that images array, which is the result of image r dot map. But now we need to think about the callback function here, right? So in each iteration of the array, we have one image, and we want to use the create image function to load that image. Now this function here returns a promise, right? And so we should await that promise. Otherwise, nothing is going to happen. And so here we need to make this function an async function so that then in there we can use await. All right. So let's actually pause this one here just as instructed. And instead we will call load all with this test array. All right. And then the instruction was also to check out this images array. So images. Okay. And so now let's take a look at the console. Let's make it a bit bigger again here. And so what we got here are actually 3 promises. So we have an array of promises and not the images themselves. And this is actually a big source of confusion for most async await beginners. And I actually remember really well when I first stumbled upon this problem and didn't really understand why this was happening. However, with all the knowledge that you just learned in this section, if we really think about this, then it might actually make sense. So here we have an async function, right? And this is an arrow function. So we have an implicit return. So this is like returning something from this callback function in each iteration, right? However, as we already know, an async function will always return a promise and not really the value that we're interested in, right? Instead, the value that we want to return is going to be the fulfilled value of the promise that the async function returns. Remember that? And so that is exactly what is happening here, but it is happening simply 3 times. So we are returning something 3 times from an async function here, and so therefore the result will be 3 promises. Okay? So just like it happened in that lecture where we attempted to return a string from one of the functions. Remember that? So here it is indeed the exact same situation. So again, we end up with this array of promises. Okay? But of course, behind the scenes, the images are already being loaded, and so we're basically fine. So all we need to do now is to get these image elements themselves out of the promise. So how can we do that? Well, we could take each promise out of the array and then manually await it, but that wouldn't make much sense. First, because we would have additional work, and second, because then that work would not be happening in parallel, right? But we want it to be happening in parallel, and therefore we can use promise.all. So promise.all is perfect for this because it already expects an array of images. And so this images array is already perfect to handle by this function, right? And so now we simply need to store the image elements here. So let's call it that into this array. So let's then take a look at that. And so now this is, of course, going to take some time. So this can only happen once the images are actually loaded. And so now, indeed, here we go. All right. So here are the 3 image elements, and they're now hidden. And so that's why we need to add the parallel class later. So again, this worked because here in this loop, of course, the await keyword did its job of pausing the execution of the function, right? And so therefore, only after that, we did then promise.all to actually get the image elements out of the promises array. So this was a bit tricky, but maybe you did figure out that this is how you solve this problem. So once you need to use async await in a map method like this, which, believe me, is pretty common, then you end up with an array of promises that you can then, as a next step, handle like this. So with the promise.all combinator function. And so now the next step is actually pretty easy. All we have to do is to loop over this array and add the parallel class to it. So image element. And so now we don't want a new array. We simply want to do something on each of the elements. And so image.classList.add parallel like this. And let's get rid of this console.log here. And in our network tab, oh, this is pretty big. So you see the images are all loading there now, right? And here we go. So now we have the images nicely displayed and set side by side. Let's make it a bit smaller so we can actually see something. And indeed, there we go. Let's just see it one more time. Also here, the resource is actually loading. To see it, we need to make it even smaller. And so you see that down here, the 3 images basically started loading all at the same time, which is because of this loop here, which will of course execute these 3 callback functions all one after another. Okay. All right. And with this, we are actually finished with this challenge and also with this whole section. So make sure that you understood what we did here in this part 2, because this is pretty important. But besides that, your job is now done for this section. So really happy to still see you here and still learning JavaScript and still making progress. So well done, you can be really proud of yourself. And I really mean that. And now I see you back here next time in the next section.